Hey everyone, welcome to this Generative AI Full Course by Simplilearn. So whether you're new to AI or want to take your skills to the next level, you are in the right place. So in this course, we will start with the basics of generative AI and show you a clear learning path to help you understand this exciting technology. You learn about important AI tools like large language models, deep learning, and agentic AI, all explained in simple terms. We'll also dive into some powerful tools like OpenAI Codex, Hugging Face, LangChain, and DeepSeek, and guide you through tutorials on machine learning, reinforcement learning, and AI workflows that anyone can follow. Along the way, you'll get hands on experience with popular AI tools, learn about transformers and GANs, and also discover how AI can help you if you don't know coding through no code development. And towards the end, we'll explore advanced topics like AI benchmarking, quantum AI, and other cutting edge innovations. Plus, we will help you get ready for job interviews with special AI tools designed to give you an edge. So let's get started. Before we commence, if you're interested to master the future of technology, then the professional certificate course in generative AI and machine learning is the perfect opportunity for you. Offered in collaboration with the ENICT Academy IT Kanpur, this 11-month live and interactive program will provide you hands-on expertise in cutting-edge areas like generative AI, machine learning, and tools like ChatGPT, DALI 2, and even Hugging Face. You'll also gain practical experience through 15 plus projects, integrated labs, and live masterclasses delivered by esteemed IT Kanpur faculty. Alongside, you'll earn a prestigious certificate from IIT Kanpur, and you'll also receive official Microsoft badges for Azure AI courses and career support through Simplilearn's Job Assist program. So hurry up and enroll and find the course link in the description box below and in the pinned comments.
Hello all, welcome to this course on Generative AI for everyone. So let's start with what is Generative AI. Generative AI is a type of artificial intelligence that focuses on creating new content rather than just analyzing or recognizing patterns in existing data. So unlike traditional AI, which might be used for tasks like predicting outcomes or classifying data, generative AI can generate entirely new items such as text, images, music, and even videos that did not exist before. So at the heart of generative AI is the ability to learn from datasets. The AI is trained on massive amounts of data. This could be millions of images, articles, or pieces of music. So through this training, the AI learns patterns and structures within the data, and then it uses this knowledge to create something new. For example, if you ask a generative AI to write a poem, it will use what it has learned about how poems are structured, such as rhyme, meter, and themes, to generate a brand new poem from scratch. So the core technology behind generative AI often involves advanced machine learning models, particularly GANs, which stands for Generative Adversarial Networks, and transformers. So these models learn how to create realistic and relevant content by processing vast amounts of data and understanding the underlying patterns. For example, in GANs, two parts of the model are there. One generates content and the other evaluates its authenticity. So these work together in a sort of competition, which pushes the system to improve its ability to create convincing and realistic outputs over time. So generative AI is incredibly powerful because it can be used for many practical applications. It helps automate tasks that were once very time consuming, like content creation or design, and it also allows for innovation in areas like entertainment, marketing, and healthcare. So for example, AI can be used to create realistic video game environments or come up with product designs for business. In marketing, AI can generate personalized email campaigns or social media content at scale. However, as impressive as generative AI is, it also raises important ethical concerns. One of the major challenges is its potential for misuse, such as creating deep fakes, which are hyper-realistic fake videos. The issue is bias. So if the AI is trained on biased or incomplete data, the content it generates could perpetuate those biases. Additionally, there's a question of job displacement, as AI-generated content becomes more common in creative fields like writing or art. We'll look more about these in the following chapters. So now let's see, how does GenAI work? So generative AI works by using sophisticated machine learning techniques, as already discussed before. So the key concept behind generative AI is that it doesn't just analyze data, but rather it creates something new that mimics the patterns it has been trained on. So the technical foundation of generative AI is built on complex algorithms and models, with GANs and transformers being the most commonly used techniques. So let me just break it down in more detail. The first step is of course training phase, which is learning from data. So generative AI models are trained on large data sets that contain examples of the type of content the model is expected to generate. So for instance, if you're training a model to generate images of cats, the model would be shown thousands or even millions of images of cats so that it can learn the various features that make up a cat, like shapes, colors, textures, and so on. So this process involves a training algorithm which adjusts the model's internal parameters to minimize the difference between the generated content and the real data. So essentially, the model starts by making random guesses and gradually improves over time as it learns more about the data it's being trained on. The process of training can be computationally expensive, often requiring powerful hardware like GPUs to process large datasets quickly. So now let's move on to the key models in generative AI. So number one is GANs, which stands for Generative Adversarial Networks. So GANs are a popular architecture used in generative AI. GANs consist of two neural networks, the generator and the discriminator. So the generator's job is to create new data like images, videos, or text, while the discriminator's job is to evaluate whether the generated data looks real or fake. So here's how it works. So the generator starts by creating random content, for example, an image. So it doesn't know what a real cat looks like at first. So it starts with something that could be completely random. And then comes the discriminator's part. The discriminator then compares the generated content to real content from the training data, like some real image of the cat. And then it tries to figure out if the content is real or fake. And then the generator learns from the discriminator's feedback. Basically, the discriminator will give the feedback if the content generated is correct or not. And then the generator learns from the discriminator's feedback and tries to improve. And over time, the generator gets better at creating realistic content, and the discriminator gets better at detecting fake content. So this back and forth training process improves the overall ability of the model to create content that looks and feels real. So GANs have been used to create realistic images, generate new fashion designs, and even create human-like faces in photos. And then comes transformers. So transformers are a different architecture used primarily in natural language processing, NLP, for tasks like text generation, translation, and summarization. So the transformer model is known for its ability to handle sequential data like text, where the order of the data matters. So the main building blocks of transformers are attention mechanisms. The attention mechanism allows the model to focus on different parts of the input sequence, like words in a sentence, when making predictions. So for example, when generating a sentence, the model pays more attention to certain words in the context of the sentence to ensure the output makes sense. So here also we have two parts. First is the self-attention. So this is a key concept in transformer, self-attention. It enables the model to consider all parts of the input data when making predictions, rather than just focusing on a fixed window of data. So this helps the model to understand the relationships between words that might be far apart in a sentence. And then we have the encoder-decoder structure. So in many transformer models like BERT or GPT, there is a two-part structure. The encoder reads and understands the input, while the decoder generates the output. So the encoder takes a whole sentence and creates a representation of it, which is then passed to the decoder to generate the corresponding output. So one of the most well-known transformer-based models is the famous GPT, Generative Pre-trained Transformer, which powers tools like ChatGPT. So GPT generates human-like text by predicting the next word in a sequence based on the words that came before it. So it can produce anything from short answers to entire essays by learning from vast amounts of text data it is provided with. Now, once the training phase is done, the next phase is the data generation phase, which is creating new content. So the data generation phase is where the trained generative AI model uses the knowledge it has gained from training to create new content. So this phase involves several steps, and the type of content it generates can vary significantly depending on the model and the input provided. So the first step is input to the model. So the model needs some form of input to begin generating new content. So depending on the type of model, there could be various types of inputs. The first being the text generation. So in text generation, for example, like GPT, the input is usually a prompt or a starting sentence. So for example, if you give a prompt like write a poem about the ocean, the model will use that as a basis for generating the poem. And next we have image generation. So for image generation, for example, in DALI or GANs, the input might be a textual description of what the image should look like what image, what kind of image you want to generate. For example, it could be something like a sunset over the mountains with a clear sky. So in GANs, the input could also be a random noise vector, which the generator uses to create a detailed image. And then we have music generation like MuseNet, where the input might be a short melody or a genre specific, like write a jazz song, and the AI will then produce a full musical composition in that style. So once the input is given to the model for data generation, the next step is the transformation of input to output. So after receiving the input, the AI's job is to transform it into an output that aligns with the patterns and the structures it learned during the training phase. So the model uses its internal learned parameters to guide this transformation. So for example, in text generation, the model processes the input, sentence or prompt and generates subsequent words one after another. So based on probabilities it has learned, it predicts the next word in the sequence, considering the words before it. For example, we gave input once upon a time. So the model might predict the next word could be there. For example, once upon a time, there was, like that, leading to a coherent sentence. So for example, it would produce something like once upon a time, there was a dragon. So it continues this process until the text is complete. And then for image generation, if the input is a description, the AI will generate an image that fits that description. The generator uses what it has learned from textures, shapes, colors, and other image features from the training data. So for example, if the description was a cat wearing a top hat, the AI would combine the learned features of cats and hats to create an image that matches the description. Then for music generation, the model processes the given input, such as a short melody or a genre specification, and uses patterns learned from training on music data to create a complete musical piece. It may follow certain patterns like rhyme, melody, and chord progression that are typical for that genre. It's just use of randomness. So one interesting aspect of generative AI is the use of randomness. In many cases, the model starts with a random noise vector or some random elements as a starting point. In GANs, for example, the generator begins by producing random content like a random image and refines it through feedback from the discriminator, as already discussed before. So over time, as a generator improves, the output becomes more coherent and realistic. So in text generation models like GPT, randomness is often introduced through a sampling mechanism. The model doesn't always generate the same output for the same input, right? As you might have seen in GPT, like using ChatGPT, whenever you ask the same question multiple times, it provides a slightly different answer. So the model doesn't always generate the same output for the same input. There's a degree of randomness in choosing the next word, which leads to more varied and creative responses. And then comes iteration and refinement. So in some cases, especially with models like GANs, the data generation process is iterative. The generator produces an initial version of the content and then it is refined over multiple cycles. So each cycle uses feedback from other components of the model to improve the output. So over time, the generated content becomes closer to what humans would expect in terms of quality and realism. So once the training phase and the data generation phase is over, the next phase is of course the evaluation phase, which is assessing and improving the generated content. So once the content has been generated, we have to evaluate it. So this phase involves checking whether the generated content meets certain criteria such as realism, relevance, coherence, and creativity. So the evaluation phase can be done through both automated and human-driven processes, and it can occur in real time or in a post-generation step. So first we'll discuss about automated evaluation. So in many generative AI systems, evaluation is built directly into the model, and this is particularly common in systems like GANs, where the discriminator serves as an evaluator. So here's how it works. First is the discriminator in GAN. So after the generator produces content, for example an image, the discriminator evaluates whether the generated content is real or fake. It does this by comparing the generated content to the real examples from the training dataset that we had provided during the training phase. Now the discriminator gives feedback to the generator, guiding it to improve its content. So over time, as the generator gets better, the discriminator gets better at detecting fake content also. So this creates a feedback loop where both the generator and discriminator improve in tandem. So eventually, the generator creates content that is highly realistic and difficult for the discriminator to distinguish from real data. And then we have the self-assessment in transformers. So in models like GPT, for example, evaluation often happens internally through a process called self-attention. So the model checks how well each part of the generated output fits with the surrounding context. So if the model detects inconsistencies like strange word choices or unnatural phrasing, it will adjust its output to improve coherence. So after the automated evaluation, we have the human evaluation. So while automated evaluation is crucial, human evaluation is often needed to ensure that the generated content meets higher level expectations, right? Especially when it is a complex or creative task. So for example, it's basically used for quality control. So when generative AI is used to create marketing content or writing, human editors may review the AI generated text for things like tone, accuracy, and creativity. So even if the AI creates grammatically correct data or a correct content, a human might evaluate whether the text fits the brand's voice or whether it resonates with the target audience. And also it has to be checked for bias and ethics. So humans also play an important role in assessing whether the generated content is biased or unethical. So for instance, if an AI model is generating text or images based on biased data, human reviewers can catch these issues and make adjustments. So after the human evaluation comes fine-tuning. So once the content is evaluated, the AI model may undergo fine-tuning to further improve its output. So fine-tuning involves making small adjustments to the model based on feedback from the evaluation process. So for example, if a text generation model is consistently producing relevant or off-topic content, fine-tuning can involve retraining the model on more relevant data or adjusting the model's parameters to make it focus on most important aspects of the prompt. So for example, in the case of GANs, the feedback from the discriminator helps refine the generator's output. So the model can be trained for additional iterations to produce more realistic and high quality content. And then we have the real world testing. So once the model is generated content that meets evaluation standards, the real world testing is important. So this could involve testing the generated content in the context it's meant for, such as seeing how AI generated music fits with a film or how AI generated product descriptions perform in marketing campaigns. So real world testing helps validate whether the AI generated content truly works in its intended use case or not. So now that we have a complete idea about how generative AI works and what are the steps involved, let's see some of the GenAI applications. So generative AI has found applications in a wide range of fields, transforming industries and creating new possibilities across different domains. Its ability to generate novel content, simulate scenarios, and automate creative tasks is reshaping many areas of work. So let's explore the various categories of generative AI applications and dive deeper into each of them. So the first one is, of course, content creation. So generative AI is revolutionizing content creation, enabling the generation of articles, videos, images, music, and even entire books. So let's see how. The first one is text generation. One of the most popular applications of Gen AI is in text generation, where models like GPT are used to create human-like text. So AI tools such as ChatGPT, Jasper, and Copy AI help in creating or writing blog posts, social media content, advertising copy, and even books. These tools can assist writers by suggesting ideas, creating outlines, or generating full paragraphs based on a given prompt. They also help reduce time and effort in content creation by automating repetitive or less creative tasks. Next, we have image generation. So models like DALL-E and Midjourney are used to generate images based on textual descriptions. So for example, you could type a futuristic city with flying cars and the AI would generate a detailed image based on that description. So this has wide applications in graphic design, advertising, and video game development, where unique visual content is often needed. So these models are also used to create synthetic images for training other AI models or to generate art that would otherwise require a professional artist. And then we have video creation. So generative AI can also create videos from entire animations to deepfake videos. AI tools like Runway ML and Synsia are used to generate video content by creating realistic avatars that can speak in any language and even simulate real-world applications. So this has applications in marketing, customer support, and education. And then we have music generation or audio generation. So AI can compose original music tracks or generate audio effects. Tools like MuseNet, which is from OpenAI, and Apple Music, can create entire music compositions based on genre, mood, or specific instrument preferences. So this is especially useful for advertisements, film scoring, or even background music in apps and video games. So AI is also being used to generate realistic voices and sound effects, for example, in virtual assistants or audiobooks. So after content creation, the next we have is healthcare. So GenAI is providing or is being a game changer in the field of healthcare. For example, in drug discovery and design, one of the most promising applications of GenAI in healthcare is its ability to help design new molecules for drug discovery. So by analyzing known compounds and understanding their chemical structures, AI can generate new molecular structures that are likely to be effective against certain diseases. So for example, Atomwise and in silico medicine use generative models to propose new drug compounds, accelerating the traditionally slow and costly drug discovery process. And then in healthcare, we have the medical imaging. So GenAI is also being used in medical imaging to enhance the quality of images, detect abnormalities, or even generate synthetic images for training purposes. So models like DeepMind's AlphaFold have revolutionized the understanding of protein folding, which is crucial for drug design. AI tools can also assist in generating synthetic MRI scans, CT scans, or X-ray images, helping researchers and doctors have more data for analyzing without the need for new scans. And then we have the personalized healthcare, which is very popular nowadays. So in personalized healthcare, GenAI can help create personalized treatment plans based on a patient's unique health data. It can also predict how patients might respond to different treatments, enabling doctors to make more informed decisions about care. And then we have the field of entertainment and media, where we have the film and animation. So Gen AI is used in film production to create visual effects, generate character designs, and even script writing. So AI-powered animation tools can generate facial expressions, voices, and movements for characters. So for example, deepfake technology has been used to create realistic simulations of actors' performance, which we see nowadays on social media, allowing filmmakers to reuse older footage or generate entirely new scenes with minimal resources. And then in entertainment and media, we have game development. So for example, in video games, generative AI helps in generating vast dynamic environments and creating new characters, plots, or levels. So for example, games like No Man's Sky have used procedural generation powered by AI to create millions or unique planets, each with different ecosystems and environments. And then again, already as discussed before, we have music and soundtracks. So beyond just generating individual songs, AI can also create soundtracks for movies and video games. And then we have business and marketing. So Gen AI is enhancing business operations. For example, a Gen AI can be used in creating highly personalized marketing content for specific customer segments. It can automatically generate email campaigns, blog posts, social media content, and even custom advertisements tailored to a customer's preference. And then there are chatbots and virtual assistants. So AI-powered chatbots such as ChatGPT or Dialogflow are becoming more intelligent in handling customer queries. So these systems are not only used for answering frequently asked questions, but also for generating contextually appropriate responses, assisting with lead generation, and even crafting sales pitches tailored to specific outcomes. And then we have the product and service design. So in product development, GenAI can help design new products or services by analyzing consumer feedback, market trends, and existing products. And then we have education and training. So Gen AI is transforming the education sector nowadays, where we have personalized training. So AI can create customized learning paths based on a student's progress, strengths, and weaknesses. So for example, a Gen AI system could adapt lessons, quizzes, or explanations based on learners' pace and understanding. And then we have content creation for learning. So Gen AI can automatically create educational materials such as worksheets, flashcards, quizzes, and even study guides based on existing content. And finally, we have the synthetic data generation. So in many fields, generating synthetic data is a crucial application of Gen AI, especially when real data is difficult to obtain or too costly to generate. So by creating realistic artificial data sets, AI can simulate real-world scenarios for research, training, or development processes. So the first one is data augmentation for AI models. Gen AI is used to generate synthetic data that augments real-world data sets, especially in computer vision or natural language processing. So for example, AI can generate images of objects or scenes that are underrepresented in existing data sets, helping improve the performance of machine learning models. And then we have the privacy preserving data. So for example, in sectors like healthcare or finance, generating synthetic data can help create datasets that protect the personal privacy of the patients. So these datasets can be used to train AI models without exposing the sensitive information such as medical records or financial transactions. So now that you've got a clear picture of what is generative AI and how it works, now let's go into a deeper understanding how generative AI creates content. Hi, also in this chapter, we'll see how generative AI creates content. So AI models, particularly those in the domain of NLP, learn and generate text by using deep learning techniques, primarily through the use of neural networks. So let's explore the technical details of how AI models like GPT and similar architectures learn and generate text. So the first step is pre-processing and tokenization. So before an AI model can start learning from text data, the data that we give, must be first pre-processed and tokenized. So here's how it works. First, we have the text pre-processing step. So here, the text data is typically cleaned and formatted to remove noise like punctuation, special characters, or irrelevant words. So text may be normalized by converting everything to lowercase, removing stop words, example the, and, or correcting spelling errors. So the goal is to prepare the data for efficient processing by the AI model. And then comes tokenization. So tokenization is a process of converting text into smaller units called tokens. So tokens can be words, subwords, or even characters. So for example, the sentence AI model learn and generate text might be tokenized into words, like separate words as tokens, like AI models learn as separate tokens. So for example, here you can see this is a sample text. So here they have tokenized each word, but can also tokenize each, letters or a group of letters. So for example, if it's generating, the word is generating, it can also tokenize it as gen, one token, ER, one token, and ating is another token. So this allows the model to understand and generate less common or compound words that isn't seen before. So the next step comes training the AI model. So the learning process of AI models is typically based on deep learning, a subfield of machine learning where models are trained using neural networks. So here's how it works. First, let's talk about neural networks. So these networks consist of layers of interconnected nodes called neurons that mimic the structure of the human brain. So the most common neural network for NLP tasks are feed-forward networks, RRNs, and transformers. So transformer-based models such as GPT have become the state-of-art architecture for NLP due to their superior performance in handling sequential data like text. Then we have training with large data sets. So to train the model, vast amounts of text data are used. So these data sets are typically scrapped from books, websites, articles, and other written content. So the model learns by analyzing the context in which words appear, understanding the relationships between them, and developing a general understanding of language. And then we have the objective of training. So the core objective of training a text generation model is to minimize loss function, which measures how far off the model's predictions are from the actual data. So the most common loss function for text generation tasks is cross entropy loss, which evaluates how accurately the model predicts the next word in a sequence of words. So during this training process, the model is given a sequence of words or tokens and is asked to predict the next word in that sequence. So for instance, in the sentence, the cat is on the dash, the model would be trained to predict words like mat, roof, or similar words based on the context. So the model adjusts internal parameters through a process called backpropagation, which allows it to learn from its mistakes and improve over time. So next comes transformers and attention mechanism. So the transformer architecture is particularly important in modern text generation models. It relies heavily on a mechanism called self-attention. We have already discussed about it slightly before. Now we'll see it in more detail. So we'll just see how it works. So the first step is self-attention. So in a sequence of words, not all words are equally important for understanding the meaning of other words. So the attention mechanism allows the model to weigh each word's importance in relation to others. So for instance, in a sentence, if there's a sentence, the quick brown fox jumps over the lazy dog. So the model needs to focus on fox and jumps when predicting the next word after the quick brown fox. Then comes the attention score. So the attention scores are basically calculated using a mathematical operation that compares each word or each tokens in the sequence to other words. So the result is a set of attention weights that tells the model which part of the sentence to attend to when making predictions. And then we have the multi-head attention. So the transformer models use multi-head attention, which involves running the attention mechanism in parallel over different parts of the input, allowing the model to focus on different relationships between words simultaneously. So these help the model capture a variety of linguistic patterns such as long-range dependencies. And then there is position encoding. So unlike traditional sequential models like RNNs, transformers don't process words in order, meaning they don't inherently capture the sequential nature of language. So to account for word order, transformers use positional encoding, which adds information about the position of each word in the sequence. So this ensures that the model understands the relative positions of words in a sequence, which is crucial for tasks like generating coherent sentences. Now the next step is generating the text. So once a model is trained, it can be used to generate text. So here's the process. The first one is of course input prompt. So text generation that we give, which is a seed or a starting point for the model. So this could be anything from a simple as a single word or a short phrase. Next is the prediction process. So the model generates text token by token. So it predicts the most probable word, the most probable next token based on the context provided by the input and the previous tokens it has already generated. And then there are sampling methods. So there are different methods to sample the next token. So one of it is greedy search. So the simplest approach is to always pick the most likely next word. So this can produce fluent text but may lack creativity or variation. And then we have samplings like top K sampling, where instead of picking the single most likely word, the model samples from the top K most likely word. And then there is also temperature sampling, where this method adjusts the probability distribution of the next word based on a temperature parameter. So higher temperature leads to most random selections, while a lower temperature makes the model more deterministic and focused on most likely words. And then there is contextual understanding in generating text. So as a model generates text, it uses the context of the previously generated tokens to inform the next predictions. So this is especially important for maintaining consistency and logic in the generated text. So for instance, the model might need to keep track of a specific character's name or a story setting to ensure that the output, the tone of the output or the style of the output remains relevant. So once the text is generated, we have fine-tuning and transfer learning as the next steps. So first, let's talk about fine-tuning. So after the model has been pre-trained on a large data set, it can be fine-tuned on more specific data to improve its performance on particular tasks. So for example, if a model is trained to generate general text, it can be fine-tuned on a data set of legal documents, medical literature, or product reviews to make it more specialized. And then we have transfer learning. So transfer learning means it's a key feature, especially in modern NLP models. So a model trained on one task or domain, for example, let's take general text generation. It can be fine-tuned and adapted to perform well on different tasks with less data. So this helps make generative AI models more adaptable and efficient. So now that you have seen how generative AI creates content, let's talk about LLMs or large language models. So LLMs have become one of the most powerful and transformative technologies in the field of AI. They leverage mass amounts of text data and deep learning techniques to generate, understand, and process human language. So let's explore the technical details behind the power of LLMs and understand why they are so influential in the AI world. So first, let's see what is LLM. So a large language model is a type of neural network based model designed to process and generate human language. So LLMs are built using deep learning techniques that are typically trained on enormous datasets containing billions or even trillions of words. They consist of billions of parameters, which are the weights of connections in the neural networks, which makes them extremely powerful at understanding and generating language. So the core idea of LLM is to use statistical patterns in text to predict the likelihood of a word or phrase given its context, enabling them to generate contextually relevant and human-like responses. So for example, models like GPT-3 by OpenAI or BERT by Google can be fine-tuned to perform specific tasks like answering questions, translating languages, or summarizing text. So let's look at the architecture behind the LLMs, which are transformers. So the architecture behind LLMs are the transformers. We have already discussed about transformers in detail in the previous chapter. So first is the self-attention mechanism. So the self-attention mechanism, as already discussed, is central to transformers, and it allows the model to weigh the importance of each word in a sentence relative to every other. So for example, in the sentence "the cat sat on the mat," the word cat is most likely related to sat than to mat, right? So the self-attention mechanism helps the model capture these relationships, allowing it to understand the context better. So the model also calculates attention scores by comparing each word with every other word in the input sequence. Next, we have multi-head attention. This also we had discussed before. So transformers use multi-head attention, where the attention mechanism runs in parallel across multiple sets of attention heads. So each head learns to focus on different aspects of the input sequence, which helps the model capture diverse relationships and patterns within the data. And then we have the positional encoding. So since transformers do not process data sequentially, they use positional encoding to ensure that the model knows the position of each word in the sequence. So this encoding is added to the input embeddings, allowing the model to understand the order of words and how context is built throughout a sentence or a paragraph. And the next step is training large language models, where we have pre-training, where the model is first pre-trained on vast text data, which is a process known as unsupervised learning. So in this phase, the model learns to predict the next word in a sentence. So during pre-training, the model develops a deep understanding of how language works by looking at the relationships between words, phrases, and sentences. And then we have fine-tuning. So after pre-training, the model is fine-tuned using supervised learning on more specific data sets for specialized tasks such as question answering, text classification, or summarization. So in this phase, the model learns how to apply its language understanding to specific use cases. Next, let's see the key features of LLMs. So there are several features which contribute to the remarkable performance of large language model. So let's see one by one. The first one is the scale of parameters. So LLMs are called large because they have an enormous number of parameters, right? The learnable weights within the model. So for instance, GPT-3 has 175 billion parameters, while some newer models like GPT-4 or PaLM, which stands for Pathways Language Model, have trillions of parameters. So the larger the number of parameters, the more data the model can process, and the more complex language patterns it can learn. So the performance of LLMs improves significantly as the number of parameters increases, and this is known as scaling. For example, parameter scaling. So larger models can better capture linguistic nuances, understand longer texts, and generate more human-like text. And then the next parameter, the next we have zero shot, few shot, and many shot learning. So LLMs are capable of performing tasks without needing extensive task-specific training. These models are, the first one is zero shot learning. This means basically performs tasks without any examples. So for example, a well-trained LLM can answer a question it has never been explicitly trained to answer. Then we have few shot learning, which performs tasks with just a few examples to guide the model. So for instance, if given a few examples of how to summarize articles, the model can generalize and apply this to new articles. And then we have many shot learning, which performs tasks with many examples, which is the typical case for fine-tuning on a specific dataset. So this flexibility allows LLMs to handle a wide range of applications without needing extensive retraining for each task. And then we have contextual understanding. So LLMs have a deep understanding of context. They can maintain coherent long-term dependencies, making it possible to generate text that is not only grammatically correct, but also contextually appropriate. So for example, GPT-3 can generate long paragraphs of text that make sense logically and follow the prompt closely, showing a remarkable understanding of the relationships between concepts, facts, and reasoning. So now let's see some of the applications of LLMs. It can be used in text generation. So LLMs can generate high quality, human-like text for a variety of purposes, such as article writing, creative writing, and advertising. It can be used in machine translation. So LLMs like GPT-3 and BERT are used in automatic translation systems, providing accurate translations between languages without requiring a direct mapping. Then it is also used in summarization. LLMs are used to generate summaries of long documents, articles, or books. Then it's also used in question answering. So by understanding and processing the context of a question, LLMs can provide precise, relevant answers to a wide range of queries. So this application is mainly useful for virtual assistants like Siri, Alexa, and customer service bots. Then it's used in sentiment analysis. So LLMs can be trained to classify and interpret the emotional tone of a piece of text, such as detecting whether a tweet or a review is positive, negative, or neutral. So this is widely used in social media analysis and market research. And it can also be used, as told before, in chatbots and conversational agents. So LLMs are widely used in chatbots, virtual assistants, and customer service applications. So now let's see some of the challenges and limitations of LLMs. So while LLMs are incredibly powerful, of course, they are not without their challenges and limitations. So the first one being bias and fairness. Now LLMs can inherit biases present in the training data, which can result in unfair or unethical outputs such as gender or racial bias in text generation. So this is a major concern in AI ethics. Then comes the computational cost. So training LLMs requires vast computational resources, which can be expensive and environmentally costly. And then comes the problem of interpretability. So LLMs are often considered the black box models, meaning it can be difficult to understand exactly how they make decisions. So this lack of transparency can be problematic in high stakes applications like in healthcare or law. And then we have the data privacy concerns. So LLMs, as you know, are trained on publicly available data, and it may inadvertently memorize and reveal sensitive or private information, raising concerns about data privacy and security. So next, let's see when does AI generated content works well and when it doesn't work well. So first, let's see when does AI generated content works well. So the first one is in repetitive and structured tasks. So AI excels in generating content for tasks that follow a predictable structured pattern. So this includes tasks like product descriptions. So AI can generate bulk product description, particularly when the format is consistent. For example, tools like Copy AI or Jasper can automate the creation of thousands of product descriptions in no time, and that can be used in reports and data-driven content. So AI can generate data-driven reports based on structured data, for example, financial results, sports scores, or weather reports. And it can also be used in email and marketing campaigns. So AI can generate personalized marketing emails or social media posts quickly and efficiently. Next, it can be used in content personalization. So AI can analyze vast amounts of data to create highly personalized content, and this is beneficial in areas like email marketing. So AI can write personalized subject lines, content, and calls to action based on a customer's browsing history, purchase behavior, and preferences. So, for example, AI-driven tools like Posado are already helping brands personalize their marketing materials at scale, at large scale. And then we have recommendation systems. So, as we all know, in platforms like Netflix, Spotify, or Amazon, AI-generated content recommendations, it can be like movies, songs, or podcasts, are highly effective at suggesting items users are likely to enjoy based on their past behavior. Then we have areas of creative and experimental work, which includes art and design. So AI models like DALI 2 and Midjourney are incredibly effective in creating visual art illustrations or design concepts from text prompts. So designers use AI to quickly generate design options and explore creative possibilities. And then comes the storytelling. So AI generated stories or scripts can help authors, screenwriters, or content creators generate ideas or overcome writer's block. So tools like ChatGPT can draft stories or plot lines based on simple inputs, helping authors develop initial drafts or experiment with different narrative structures. And then it can be used in music composition also. Next, it can be used in large-scale content production. So for large-scale content production, where speed is critical, AI can generate vast quantities of content rapidly. So for example, content for SEO. AI can generate blog posts, articles, or web copy optimized for SEO, helping businesses keep their websites up to date with fresh, keyword-rich content. And then in content creation or content curation. So AI can help with curating content from various sources such as news aggregation by pulling relevant articles and data. And then it can also be used in language translation. So AI models, particularly those based on transformers like Google Translate and DeepLearn, are highly effective at translating text between languages. So these systems can handle vast amounts of text and provide real-time translations. So now that we have seen when AI generated content works well, next let's see when it doesn't work well. So the first one is in creative nuance and context. So while AI can generate creative content, it often struggles with deep emotional nuance. So AI often lacks a true understanding of human emotions and struggles to generate content that truly resonates on a deep emotional level. So for instance, a piece of content that's meant to evoke compassion, humor, or grief might fall flat because the AI doesn't genuinely feel those emotions. And then there is cultural sensitivity issue. So AI models trained on large data sets can inadvertently produce content that is culturally insensitive or inappropriate. Next is originality and intellectual property concerns. First one is lack of true originality. So AI is capable of producing content that appears original, but is fundamentally based on patterns it has learned, right? So this means AI generated content can sometimes lack true originality, which you might have faced while generating content, and can unintentionally replicate the existing ideas or phrases. And then there is a risk of plagiarism. So AI tools trained on large data sets may generate content that's too similar to existing work, leading to plagiarism concerns. The next, there is complex tasks requiring expertise. Where highly technical writing comes. So while AI can generate content on a variety of topics, it struggles with complex specialized subjects like advanced scientific research, intricate legal analysis, or deep medical knowledge. So for instance, in areas like legal documentation, the precision and the attention to detail required often go beyond AI's current capabilities. And then there is subjective judgment. So AI lacks the ability to make subjective or qualitative judgments that are often needed in areas like art, criticism, literature analysis, or evaluating ethical dilemmas. And then there is bias and ethical concerns, which we have already discussed in the limitations. And then there is quality control and inconsistent output. So although AI has made significant strides in content generation, it often still struggles with maintaining quality, consistency, and coherence. And then there is legal and compliance issues. So in fields like healthcare or finance, AI generated content needs to follow strict guidelines. So for instance, an AI generated financial report or medical advice might inadvertently violate legal regulations or industry standards. And then there is also an issue of copyright. So AI generated content, especially art and writing, may raise questions regarding ownership. Who owns the rights to content generated by an AI? Is it the creator who prompted the AI or the company that developed the model? So these legal gray areas can create complications in industries where intellectual property rights are crucial. So now in the next chapter, we'll see how generative AI is used in businesses. How does companies use generative AI? So AI is increasingly being adopted by businesses across various industries to improve productivity, save time, and streamline operations. So here's a detailed breakdown of how businesses are leveraging AI to achieve these goals. So the first one is AI-powered chatbots for customer support. So one of the most common uses of AI in business is through AI-powered chatbots, which are transforming customer service by providing instant round-the-clock support. So here's how it works. First is instant customer interaction. So AI-powered chatbots are available 24/7 and can handle multiple customer queries simultaneously. So they can answer frequently asked questions like FAQs, provide information about products or services, and process simple transactions and resolve common issues. So for example, LivePerson, a company offering AI chatbots, powers brands like Vodafone and HSBC. So these bots can handle inquiries about account balances, service status, and more, significantly reducing the wait times for customers. Then there is cost efficiency. So with AI chatbots handling routine inquiries, businesses reduce the need for a large human customer support team. This leads to cost savings on staffing and training while maintaining a high level of customer satisfaction. So for example, Sephora, the cosmetics retailer, uses an AI-powered chatbot named Sephora Virtual Artist to assist customers in finding makeup products based on their preferences, giving personalized recommendations and beauty advice. And then it leads to improved customer satisfaction. So AI chatbots provide quick and consistent responses, reducing customer frustration. They also have the ability to analyze customer sentiment and escalate the complex issues to human agents when necessary. So for example, Mitsubishi Electric uses AI chatbots to quickly address technical inquiries from their customers, streamlining the support process and ensuring faster response time. So next, it is used in AI-generated marketing content and business reports. So AI is a powerful tool for automating content generation, as we have discussed multiple times in this course. So the first is marketing content creation. So AI tools like Jasper AI and Copy AI are used to generate blog posts, email newsletters, social media posts, and product descriptions. So these tools can produce large volumes of high-quality SEO-optimized content quickly. So for example, Airbnb uses AI-powered tools to create localized content and personalized promotions for users. So by automating much of the content creation process, Airbnb can run personalized campaigns more efficiently. Next, there is automating business reports. So AI is widely used for generating automated business reports, including sales, financial, and operational reports. AI models can pull data from various sources, analyze it, and create comprehensive reports with actionable insights. So for example, Tableau, which is a data visualization company, integrates AI with its platform to generate automated reports and business intelligent insights. So this allows businesses to make data-driven decisions more quickly without needing a dedicated data analyst. And then there is personalized marketing campaigns. So AI can analyze customer data, including preferences, browsing history, and purchase behavior to create personalized marketing campaigns. So for example, Netflix uses AI algorithms to generate personalized recommendations for each user based on their viewing history. So this approach has contributed significantly to customer retention and engagement. Next, it is used in automating repetitive tasks with AI. So as you know, AI is a game changer when it comes to automating repetitive tasks that takes up significant amounts of employee time. So first, it can be used in data entry and processing. So AI systems can automate data entry, reducing human errors and saving employees time. So for example, AI can extract relevant information from documents and automatically input it into the correct fields in a database or enterprise resource planning ERP system. So for example, UiPath, a leading automation company, offers AI-powered robotic process automation or RPA tools that automate repetitive business tasks such as invoice processing, payroll management, and customer account updates. Next, it can be used in customer relationship management, CRM. So AI is often integrated into CRM systems to automate the tasks like lead generation, follow-up emails, and customer segmentation. So for example, HubSpot and Salesforce offer AI-powered CRM tools that automate lead scoring, email follow-ups, and sales pipeline management. And then it can be used in document management and legal work. So AI can automatically organize and categorize documents, which saves legal teams and other departments a great deal of time. So for example, Kira Systems uses AI to analyze contracts and legal documents quickly, identifying relevant clauses and potential risks. So this speeds up the contract review process, allowing legal teams to focus on high-level strategy. Next, it is used for predictive analytics. So businesses are increasingly using AI for predictive analytics, which helps forecast future trends and customer behavior. So for example, it's used in sales forecasting, where AI can analyze historical sales data, seasonal trends, customer behavior, and external factors like economic conditions to predict future sales. So this helps businesses plan production, inventory, and marketing strategies accordingly. So for example, Amazon uses AI to predict customer demand and optimize its inventory management. The AI models anticipate what products will be in demand based on historical data, time of year, and even social media trends, ensuring products are available when customers need them. Then it is used for supply chain optimization. So AI can optimize supply chain management by predicting demand fluctuations, identifying bottlenecks, and automating procurement processes. So for example, Walmart uses AI to forecast demand and optimize stock levels across its global supply chain, reducing waste and ensuring stores are stocked with the right products. Next, AI is also bulkily used in hiring and talent management. For example, it is used in automated recruiting where AI tools can analyze resumes, screen candidates, and even conduct initial interviews. So these tools help HR teams save time by identifying the best candidates based on qualifications, experience, and even cultural fit, often with less human bias. So for example, HireVue uses AI to analyze video interviews, assessing candidates' responses, tone, and body language to recommend the most suitable candidates. This speeds up the hiring process and helps eliminate bias. Also, it can be used in employee performance and retention. So AI can analyze employee performance, monitor engagement, and predict when employees might leave, helping businesses take action to retain talent. So for example, Workday integrates AI with its human resource management system to predict employee turnover and identify at-risk employees, allowing businesses to take proactive steps to improve retention. Then AI is also widely used for customer insights and market research. So AI tools can process and analyze vast amounts of customer data, providing business with insights that were previously difficult to gather. First, it can be used in sentiment analysis. So AI can analyze social media, reviews, and customer feedback to gauge customer sentiment toward products, services, or brands. So this helps businesses understand the public opinion about them. So for example, the Brandwatch uses AI to perform sentiment analysis on social media mentions, enabling companies to track customer opinions and identify emerging trends. And then there is market research. So AI-powered tools can also automate market research by analyzing industry data, competitor activity, and customer preferences. So for example, Crimson Hexagon uses AI to analyze millions of social media posts, blogs, and news articles to provide businesses with insights on consumer behavior and emerging market trends. So now that we have seen that how businesses use AI in different scenarios or different purposes, now in the next chapter we'll see how are these AI models built and being customized for these purposes. I also in this chapter we'll see how are these AI models built for customization. So basically we are fine-tuning the AI models. But what is fine-tuning? So fine-tuning is a critical concept in machine learning, particularly in the context of transfer learning, where a pre-trained model is adapted for a specific task or application by further training on a smaller specialized dataset. So the idea behind fine-tuning is to take advantage of the general knowledge a model has already learned from a large dataset and adjust it to perform better on a more specific problem without having to start from scratch. So in simpler terms, fine-tuning is a process of taking a model that has been already trained on a general task, such as it can be language modeling or image recognition, and then it is retrained with more specific data that reflects the nuances of the new task. So this process allows the model to apply its pre-existing knowledge to a more focused, specialized area, enhancing its performance for a particular use case. So that's how it is fine-tuned. A AI model which is, trained for general tasks are fine-tuned for a specific task, and then it is used for specific business use cases, as we saw before, which were the use cases. So now let's see why is fine-tuning important. So the first one is efficiency. So training a machine learning model from scratch can be computationally expensive and time-consuming, especially for complex models with millions or billions of parameters. So fine-tuning allows you to save time and computational resources by leveraging a model that has already learned general features. So the model only needs to be trained on the task's specific data for a short time to adapt to the new domain. Next is generalization. So pre-trained models, especially large models, have often been trained on vast datasets containing diverse information. So as a result, they have a rich understanding of the broader structure and relationships within the data. So fine-tuning helps the model take this broad knowledge and apply it to a specific context, improving the model's ability to generalize to real-world data related to that task. Next is performance boost. So fine-tuning typically leads to a significant improvement in the model's performance for a specific task. This is because the pre-trained model has already learned useful features such as patterns in language or objects in images or sentiments in text. And fine-tuning helps the model specialize in the exact problem you need to solve. And the next importance is of customizability. So fine-tuning allows businesses or researchers to customize pre-trained models to their specific needs or use cases without requiring deep expertise in training large-scale models. So whether it's adapting a model for sentiment analysis, customer service, or medical diagnosis, fine-tuning ensures that the model performs well in the intended context. So now let's see some of the areas or cases where fine-tuning works. So fine-tuning works by taking a pre-trained model and updating its parameters, right? So here's a detailed explanation of how the process typically works. So now let's see how does fine-tuning work. So the first step is starting with a pre-trained model. So fine-tuning usually starts with a pre-trained model. These models have been trained on vast datasets containing a variety of information. So for instance, GPT-3, which is a large language model, has been trained on large amounts of text from books, websites, and other sources to understand language broadly. Similarly, ImageNet models for computer vision are trained on millions of labeled images across various categories. So these pre-trained models have learned general representations like identifying objects or understanding sentence structures. The next step is selecting the fine-tuning dataset. So after choosing a pre-trained model, the next step is to gather a specific dataset related to the task or domain. So for example, if fine-tuning a language model for customer service, the dataset might include customer interactions, support tickets, or chat logs. Or if fine-tuning an image recognition model for medical imaging, the dataset might consist of X-rays or MRIs labeled with specific diagnosis. So once the fine-tuning dataset is selected, the next is freezing the initial layers. So in many fine-tuning processes, some layers of the pre-trained model, typically the early layers, are frozen, meaning that their weights are not updated during the training. So these early layers capture basic features, which are useful for many tasks. But freezing these layers, the model can retain its general understanding and only fine-tune the layers which are only responsible for more complex or domain-specific representations. So once that is done, the next step is training on the new task. So fine-tuning involves training the model on the new task-specific dataset, but unlike initial training, this step requires much less data and computational power. So the model is trained with a lower learning rate, so the adjustments to the weights are subtle, allowing the model to retain the broad knowledge it gained from the pre-training phase while becoming more specialized in the task at hand. So during this process, the model gradually adjusts its weight to minimize the error or loss when performing the task. So for example, if fine-tuning a text classification model, the model will adjust its internal parameters to predict the correct category for new text samples. So once the training on the new task is done, the next step is for evaluating and fine-tuning it further. So after fine-tuning, the model is typically evaluated on a separate validation dataset that wasn't part of the fine-tuning process. So this helps assess how well the model generalizes to new data and whether it has learned the task effectively. So if the model doesn't perform as expected, further adjustments may be made, such as tweaking the dataset, training parameters, or model architecture. And finally, we'll be deploying the fine-tuned model. So once the fine-tuning process is complete and the model is performing well, it can be deployed for its specific task. So the fine-tuned model is now capable of handling tasks within its specialized domain, which can be examples such as answering customer queries or diagnosing medical images or providing accurate sentiment analysis and so on. So now let's see some of the examples of fine-tuning in practice, in real-life practice. So we'll take an example of fine-tuning a language model for sentiment analysis. So the first step would be to start with a pre-trained language model, which has been trained on a large, diverse text corpus. And then the step 2 would be to collect a task-specific dataset for sentiment analysis, such as a collection of customer reviews which are labeled as positive, negative, or neutral. The next step will consist of fine-tuning the model on this dataset by adjusting the model's weights so that it becomes better at classifying the sentiment of reviews. Step 4 would be evaluating the fine-tuned model on a test set of customer reviews to ensure it can correctly classify the sentiment. And finally, to deploy the model to analyze the sentiment of new customer reviews or social media comments automatically. So these are the steps to be followed while fine-tuning for a specific use case. So now let's see, when do these businesses need to train their own AI models? So businesses may need to train their own AI models in certain situations where pre-trained models or third-party solutions are insufficient for their unique requirements. So training custom AI models can provide a more tailored solution, allowing businesses to better address specific problems and use cases. So the first scenario would be for unique or specialized use cases. So for example, if a business operates in a niche industry or needs a solution for a highly specific task, pre-trained models may not perform well because they have been trained on a general data and might not be optimized for specialized requirements. So in such cases, training a custom model allows businesses to focus on their particular needs. So for example, a healthcare company may need an AI model that can analyze medical images for rare diseases or conditions that are not well represented in existing public dataset. So off-the-shelf models trained on general medical images might not be effective in detecting these rare conditions. So the company would need to train its own model on specialized medical image data. Next is, for example, a legal firm might need an AI model that can understand the nuances of specific legal terminology or interpret complex legal documents, requiring training on a dataset composed of case law, legal contracts, or regulations. Next, it can be used in the scenario of proprietary or private data. So businesses that deal with proprietary, private, or when they deal with sensitive data, it might prefer to train their own models to maintain control over their data and ensure privacy. So using pre-trained models from third parties could expose sensitive business data to external entities or compromise data security. So for example, an e-commerce platform may want to build a recommendation engine using data from its own users, such as browsing behavior, purchase history, and preferences. Since this data is proprietary, using third-party models may expose private customer information, prompting the business to train its own model. Next is, for example, a financial institution might want to develop fraud detection algorithms using their internal transaction data, customer profiles, and historical fraud patterns. So by training their own AI models, they can ensure that sensitive financial data remains within the organization. Next is the case of improving accuracy for domain-specific tasks. So pre-trained models can be good starting points, but they may not always deliver the level of accuracy required for high-stakes application. So when accuracy is crucial, especially for specialized tasks, training a custom model can help businesses improve performance significantly. So for example, a customer service chatbot using a pre-trained language model might be good at handling general inquiries, but struggle with understanding complex domain-specific queries. So training a custom model with a dataset of specific customer interactions, FAQs, and industry-specific jargon can make the chatbot more accurate in resolving issues. Next is the example of autonomous driving. A company may want to train its own model to recognize specific road signs, obstacles, or driving conditions that are unique to certain regions or environments. So pre-trained models might not be sensitive enough to these specific use cases, requiring the business to train a model with localized data. Next comes the performance and efficiency requirements. So pre-trained models are often large and computationally expensive, which might not be suitable for businesses with limited resources or those requiring real-time performance. So for example, a company building a mobile app for real-time image recognition might not want to rely on a large pre-trained model due to the constraints of mobile devices. So instead, they may train a smaller and more efficient model that can run locally on the device. Also, for an industrial application where AI is used for equipment monitoring in real time, a business may need to train custom models to process sensor data quickly and accurately. So pre-trained models could be too slow or not optimized for the specific types of data the business collects. Next, it can be used for areas in custom features or interactions. So sometimes businesses need to train models to incorporate custom features or understand unique patterns of interaction that pre-trained models cannot capture effectively. So for example, a retail business may want to build a model that recommends products based on a combination of historical sales data, inventory levels, and real-time customer behavior. So generic recommendation model may not take up all these features into account. Also, financial service provider may want to develop a credit scoring model that takes into account non-traditional data sources. So in these cases, the business would need to train a custom model that processes and interpret this unique type of data. Next, it can be used in cases for regulatory and compliance requirements. So certain industries are highly regulated and require AI systems that meet strict legal and ethical standards. So as you know, pre-trained models may not comply with these regulations, and businesses may need to build their own models. So for example, in a healthcare company, it might need an AI system for diagnostic purposes that complies with medical standards. So pre-trained models that might not meet these standards. So training a custom model ensures compliance with these legal frameworks. Also, a company in the financial industry might need to ensure that its AI models used for risk assessments are transparent, explainable, and fair to meet certain regulations. So training models internally ensures that they can be adjusted to meet these legal requirements. And finally, it can be used for ethical considerations and bias control. So businesses aiming to ensure fairness and minimize bias in AI models may prefer to train their own models to have more control over data and algorithms. So for example, a company developing an AI tool for hiring might need to train their own model to ensure that it minimizes gender, racial, and other biases in recruitment. Also, an organization working in social service may want to train a custom model to assess eligibility for benefits, ensuring that the model is free from biases. So now that you know how the AI models are fine-tuned and trained for one specific use case, next let's see how we can make AI smarter with external knowledge by using RAG. Hi all, in this chapter we'll deal with how to make AI smarter with external knowledge. So for that, first we have to know what is RAG, or Retrieval Augmented Generation. So RAG, or Retrieval Augmented Generation, is a method in NLP that combines the capabilities of retrieved based models and generation based models to improve the quality of generated text. So the core idea behind RAG is to enhance the language model's output by retrieving relevant external information from a knowledge base or a database during the text generation process. So this allows the model to incorporate more accurate and up-to-date information that it might not have learned during training, particularly when dealing with specialized or complex queries. So this is how basically RAG works. So RAG is composed of two main components, which is retrieval and generation. So first, let's see the retrieval part. So in the retrieval phase, the model receives a query or input, and it retrieves relevant documents or pieces of information from an external knowledge source. So this knowledge source could be anything from a large corpus of text like books, articles, or research papers to a structured database. So the retrieval component is responsible for identifying which pieces of information are most pertinent to the input and bringing them into the process. So for example, suppose the input is a question, what is the capital of France? The retrieval component searches a knowledge base of geographical facts and retrieves documents or passages that mention the capital of France, which would typically return the information about Paris. Now the next part is a generation part. So after the relevant documents or data have been retrieved, the generation component takes part. So this part of the model uses a generative language model. It can be anything like GPT-3, T5, or BART to generate a response, incorporating both the input query and the retrieved information. So the model generates text based on the context provided by the input and the newly retrieved data. So the key benefit of this approach is that the generation model doesn't have to rely solely on its pre-trained knowledge. So instead it can augment its understanding with external real-time information retrieved from the knowledge base. So basically there's a knowledge base given from where it retrieves the data or retrieves the knowledge. So this is particularly useful for answering factual or knowledge-intensive queries where the model's internal knowledge might be incomplete or outdated. So for example, what is the capital of France? The generation component uses the retrieved information that Paris is the capital of France to generate a more complete answer. So the capital of France is Paris, which is located in the northern part of the country, would be its reply or would be its output. So here are the key features of RAG. The first one being retrieval augmented. So by augmenting the generation process with retrieved data, RAG enables the model to access external knowledge sources in real time, making it more adaptable and capable of handling more specialized tasks. Then comes end-to-end model. So RAG models are typically trained end-to-end, meaning the retrieval and generation components are trained together as part of a single model. So this allows the model to learn how to retrieve the most relevant documents and generate the most appropriate output from them, creating a unified and efficient system. And then comes real-time access to information. So unlike the traditional models, which can only generate content based on what they have learned during training, RAG models can use up-to-date and domain-specific knowledge retrieved during the generation process. So this allows the model to provide more relevant and accurate responses to specialized queries. So now let's see why is RAG useful. So RAG addresses several key challenges faced by traditional language models. So RAG addresses several key challenges which are faced by the traditional language models. The first being handling specialized queries. So pre-trained generative models may struggle with specialized or domain-specific queries because their training data is broad and generalized. So RAG helps by retrieving relevant information from specialized sources, allowing the model to answer questions about niche topics more effectively. Then it also helps greatly in reducing hallucinations. So generative models sometimes produce hallucinated information, responses that sound plausible but are incorrect or fabricated. So by retrieving the facts, contextually relevant data, RAG reduces the likelihood of hallucination or wrong replies or wrong outputs and ensures the response is grounded in real-world knowledge. And it also greatly helps in improving accuracy. So because the model has access to a more diverse set of information, RAG models can generate more accurate, detailed, and relevant answers. So this is particularly important in applications like question answering, fact-based summarization, and knowledge extraction. So now let's see some of the real-world applications of RAG. So RAG has several real-world applications in businesses, particularly in areas where high-quality, fact-based, and contextually accurate information is essential. RAG combines the strengths of both the retrieval-based models, which fetch relevant information, and generation-based models, which generate human-like responses to provide more accurate and informative results. So let's see the applications. In customer support and chatbots, so RAG improves chatbots by retrieving relevant information from knowledge bases and generating detailed, contextually accurate responses. So for example, a telecom company uses RAG to retrieve up-to-date plans and pricing, providing personalized customer support. Then it's used in content generation. RAG helps create SEO-optimized content by retrieving data from internal sources, customer reviews, and trends. For example, an e-commerce platform generates unique product descriptions based on product features and customer feedback. Then it's used in knowledge management. RAG enhances internal document retrieval and automates report generation for businesses. So for example, a law firm uses RAG to retrieve and summarize legal cases for quick access to relevant information. It's also used in question answering systems. So RAG, as mentioned, improves search engines and customer-facing knowledge bases by generating direct answers to complex queries. So for example, a medical company uses RAG to generate up-to-date answers on treatments for doctors. Then it can be used in areas such as product e-commerce by generating personalized product suggestions based on customer data. It can be used in healthcare and medical applications where RAG supports clinical decision-making by retrieving relevant medical data and generating treatment recommendations. And it can also be used in areas of research and development, where RAG aids in scientific, literature search, and technical documentation retrieval, generating summaries and reports for faster decision making. So now that we have studied the applications, what is RAG, how we can make AI smarter, and also the real world applications of RAG, now let's move on to see what are the costs of using AI. Hi, also in this chapter, we'll see the costs of using AI. So AI is revolutionizing industries and offering businesses ways to increase efficiency, but it's important to understand the costs involved in using AI, particularly how AI models charge for usage, how much it costs to generate content, the comparison between AI and human labor, and when to use AI versus hiring a human expert. So let's break down each of these concepts in this chapter. So basically, how AI models charge for usage. So AI models typically charge based on the amount of usage, which is often measured in tokens or compute resources. So the two most common ways AI models, especially language models like GPT or Claude, charge for using are: number one is for tokens. So in the context of AI language models, a token refers to a unit of text, which could be as short as one character or as long as one word. So pricing for models like GPT is usually based on the number of tokens processed, including both the input tokens, which is the text that we provide as queries or prompts, and the output tokens, which is the text generated by the model. So for example, OpenAI's GPT-3 charges based on the number of tokens. A single token typically represents about 4 characters of English text. So that's the count. Now, depending on the model and the amount of text processed, you may be charged for the input tokens, that is the prompt you give the model, and the output tokens, the generated response. So pricing varies depending on the model size. Example, Ada, Babbage, QD, DaVinci for OpenAI's models, and the total number of tokens used per interaction. So let's say, for example, if you send a prompt with 100 tokens and receive a response that generates 200 tokens. So the total cost is based on 100 input tokens plus 200 output tokens, which is 300 tokens. So prices can range from fractions of a cent per 1,000 tokens to a few dollars for larger models or complex tasks. Next, it is also charged on the basis of compute resources. So some AI models, especially for more complex tasks like image generation or video processing, charge based on compute resources they require. So this could be measured in terms of CPU or GPU hours, the storage space used, or the bandwidth consumed. So for example, Google Cloud AI, AWS, or Microsoft Azure charge businesses based on how much GPU or TPU time is consumed when running tasks, like training a custom model or generating content. So costs vary depending on factors such as the power of the infrastructure used, how long it runs, and the specific service style chosen. So let's see how much it costs to generate content with AI. So the cost of generating content with AI depends on several factors, including the complexity of the content, the type of model used, and the pricing structure. So here's an overview. So first, let's see content generation costs for text. So basic text like short form. For simple tasks like generating short paragraphs, product descriptions, or emails, AI models may cost only a few cents per output. So for example, generating 100 to 200 words using a model like GPT-3 could cost you a few cents. Then comes long form content. So generating long articles, reports, or complex stories involves more tokens and could be more expensive. So for instance, generating a 1,000-word article could cost anywhere between $1 to $10, depending on the number of tokens processed and the model used. Next comes custom training. So if businesses are using AI to generate highly specialized content, they may need to fine-tune or train a model on domain-specific data, which can incur additional costs apart from this. Next are the content generation costs for images or videos. So in image generation, AI image generators like DALL-E 2 or Midjourney typically charge per image generated. So a single image might cost anywhere between $0.5 to $5 depending on the platform and resolution. And AI video generation is generally more resource intensive, especially for high quality content. So the cost can vary widely based on factors like video length, resolution, and complexity. So for example, platforms like Runway ML or Cincia might charge hundreds of dollars per minute of high quality video. So let's say an example, if an e-commerce site uses an AI model to generate 500 product descriptions. So it might cost $20 to $100 depending on the model and the length of description. The model might process hundreds of tokens per product description, leading to more substantial costs for large-scale content generation. So having known the costs of AI, let's see an AI versus human labor, whether AI is really cheap. So one of the key benefits businesses look for in AI is its potential to replace human labor, right? particularly for repetitive or low-skill tasks. So, however, when evaluating whether AI is really cheaper than hiring a human expert, there are several factors to consider. First is for repetitive low-skill tasks. So, AI can be significantly cheaper and more efficient compared to human labor. For instance, AI-powered chatbots for customer support, automated data entry, or content generation for marketing can perform these tasks much faster than humans without the need for breaks, vacations, or training, and often at a fraction of cost. So, for example, a human customer service agent might cost a business $15 to $30 per hour, while an AI-powered chatbot might cost $0.01 to $0.05 per transaction. So, for high volumes of customer inquiries, AI becomes vastly more cost effective. Then, in areas where high skill creative or specialized tasks are needed. So, AI still faces limitations in tasks that require high level expertise, nuanced decision making, or creativity. Human experts bring a wealth of contextual understanding, emotional intelligence, and domain specific knowledge that AI models currently cannot replicate. So, for example, legal analysis, strategic business decision making, and highly creative content production often require human input. So, for example, while AI can generate basic copy for blogs or advertisements, creating a marketing campaign with a unique voice, cultural relevance, and deep understanding of customer psychology would likely still require a human marketer. Next are some of the hidden costs of implementing AI. So, while AI can appear cheaper in short term, businesses must also consider the hidden costs, such as model training, data acquisition, maintenance, and compute resources. So, additionally, fine tuning and customizing AI models for specific tasks can incur significant costs. So now let's see when to use AI versus when to hire a human expert. So choosing whether to use AI or hire a human expert depends on task's complexity, the need for creativity, and the budget constraints. So here are some guidelines. First, let's see when to use AI. So when the task is repetitive and data driven, examples including automating customer service, generating basic marketing content, processing large data sets, and creating reports or summaries. Also, AI can process vast amounts of data in seconds, whereas human work may take much longer. So, this is ideal for tasks like real-time recommendation, 24/7 customer support, and content generation at scale. Also, cost efficiency is key. So, for tasks like generating large volumes of standard content, AI is often much cheaper than hiring multiple human workers. Also, where standardization is required. So, AI is perfect for tasks that require uniformity, like generating standard emails, filling out forms, or processing invoices. So, now let's see where we should hire a human expert. So, first is, of course, where creativity and critical thinking are required. So, human experts excel in generating creative content, crafting strategies, and handling complex tasks that involve interpretation, judgment, and problem solving. So, AI still lacks true creativity and the ability to understand deep context, also in tasks which are highly specialized. So, for instance, a human expert in law, medicine, or engineering brings a level of domain expertise and nuanced understanding that AI cannot yet replicate. Also, where emotional intelligence or relationship management is required. So, human experts are essential in tasks like therapy, sales, and consulting, where empathy, understanding, and interpersonal skills are required. So now that you've got a clear understanding of where we have to use AI, Gen AI, and where we have to use a human expert, now in the next chapter, which is our last chapter, we'll see what is the future of generative AI. How does the future of generative AI look like? So in this last chapter, we will have a quick glance of how the future of Gen AI would look like. So generative AI is advancing quickly and is expected to transform numerous industries in the near future. So here's an overview of how Gen AI will evolve and its potential impact. First one is advancements in model capabilities. So the future of Gen AI will bring enhanced performance and flexibility. First is improved coherence and context understanding. So Gen AI models will become better at understanding long-term context and maintaining coherence across industries. So this means more natural conversations and better continuity in content creation. Then comes multimodal ability. So Gen AI will move beyond just text and images to handle a variety of modalities, including video, audio, and like more improvised and perfect video and audio creation. So this will allow the generation of not only written content, but also, better at visuals and voiceovers. Also in hyper personalization, AI will become more adept at generating tailored content based on real-time data. So businesses will be able to deliver highly personalized experiences in marketing, customer service, and other areas adapting to individual use preferences. Next is expert across various industries. Like healthcare, well, Gen AI can help diagnose diseases, recommend treatments, and also with drug discovery. It can be used in education, where GenAI will generate customized learning materials, adaptive quizzes, and explanations. Also, it will be more widely used in entertainment, generate unique video game narratives, movie scripts, entirely fresh content, and even entire songs. So it may also be used to create interactive and dynamic content in gaming, where the storylines evolve based on player choices. Also, it can be used in creative industries. GenAI will assist artists, designers, and writers for creation. Next is increased accessibility. So first comes low-code or no-code platforms. So with the rise of low-code and no-code tools, businesses and individuals with little technical expertise will be able to learn generation, customer interaction, and more. Also user-friendly interfaces. So future GenAI systems will likely feature voice or gesture-based interfaces. The AI in intuitive ways, making it more accessible for everyone, not just developers. So that was it, guys. Congratulations on completing the course. You have now gained a solid understanding of generative AI and its transformative impact across industries. So from content creation to automation and personalized experiences, Gen AI is revolutionizing how we work and innovate.
Are you feeling like every other video, article, or tweet you see these days is about generative AI? You're not wrong. It's the tech world's current obsession. But instead of just nodding along, wondering what it all means, what if we could actually master it? In this video, we are cutting through the hype, giving you a practical step you need to truly understand. I will be breaking down the entire journey into manageable phases from fundamental knowledge to building your own Gen AI projects. Before we begin, let me tell you what generative AI or Gen AI means. As the name suggests, it is generating data. It's a technology where it uses existing data for creating new ones. It might be in the form of text, images, audio, video, code, or even 3D models. For better understanding, I will be dividing the entire roadmap into 4 phases plus one additional phase as a bonus phase for you to excel in this field. Phase 1 is all about laying the foundation, which includes the basics of AI and machine learning. Think of artificial intelligence as making computers smart enough to do things which people can do. Machine learning is just one of the way to do it, allowing computers to learn from example instead of being told exactly what to do. It's a learning by seeing and doing it, not just by a rule book. There are 3 main types of machine learning: supervised learning, unsupervised learning, and reinforcement learning. Supervised learning is where the computers learn with correct answers, whereas unsupervised learning involves finding patterns on its own, and reinforcement learning is about learning through rewards. You will need Python too. Key tools include NumPy for numerical operations, Pandas for organizing data, and Matplotlib and Seaborn for data visualization. These help you to work with and understand data. You need to understand data preparation, which involves cleaning and organizing data. Also, learn about the feature engineering, which is the process of selecting important parts of the data of the model. Gen AI uses deep learning. You can think of deep learning as a computer network with many layers. Understand the basic idea of how these networks learn from data. This is the key for understanding more complex Gen AI models. Moving on to phase 2, where you can start exploring the Gen AI models. Some of Gen AI models include GANs, which are 2 networks competing, one making fake data and other tries to spot it. This model works well for creating realistic outputs. The second model is VAEs. This model learns a hidden representation of data to create new or similar data. The next model is transformers, which are excellent at understanding context in sequence like text, audio, and even images using attention. The last model is diffusion model, which can create high quality data by reversing a noising process. This model is very popular for images. Apart from Gen AI models, you need to cover text generation model, which falls under natural language processing, which is NLP. These models power text creation from writing articles to translating languages. And lastly, you will cover image generation using GANs and diffusion models. In phase 3, we will focus on developing our practical skills. You can start with small projects such as generating basic images or text with small datasets.
Do experiment and learn the workflow. Join platforms like Hugging Face, Reddit, Stack Overflow, and Kaggle forums to ask questions and learn from others. To showcase your work, you can use GitHub to share your projects and code. Phase 4 is truly about staying ahead. Gen AI is always changing, so you need to be aware of it. New architectures are constantly being built, so briefly be aware that more advanced models are continuously being developed beyond the basics that we have covered. I would also recommend learning about deploying models on cloud platforms like AWS, Google Cloud, or Azure, which will be useful for larger projects. Additionally, you can read research papers, follow tech experts online, whether on Twitter or LinkedIn, and stay curious about this field. Continuous learning is the key in this field. Now that you have built a strong foundation in generative AI, Phase 5 is all about mastering the future of technology. A certification course provides formal validation of specialized knowledge and skills, making individuals stand out to employees and demonstrating a commitment to professional development. This recognition often leads to enhanced credibility that improves career opportunities with specific field. Wondering which certification to go with? Don't worry, I've got you covered here as well. There are so many certificate courses available, but I would strongly suggest you to check on Applied Generative AI Specialization course by Simplilearn in partnership with Purdue University and Microsoft. This will be 16-week course which will give you hands-on learning experience on building AI and Agentic AI apps through hands-on industry-relevant projects. You will also learn popular Gen AI tools which includes gaining in exposure to Copilot, LangChain, Hugging Face, Azure AI, Studio, OpenAI, and other tools. Additionally to this, you will provide a certificate from Purdue University and course completion certificate from Microsoft. Hurry and enroll now. Find the course link in the description box and pinned comments. That's your roadmap to understanding generative AI. Start with the basics and get practical experience and never stop learning. The power of Gen AI is within your reach.
Hey everyone, welcome to the Simplilearn's YouTube channel. In this tutorial, we will learn about the MCP. Anthropic's MCP, or also known as the Multi-Agent Collaboration Protocol, is a groundbreaking framework designed to enable seamless cooperation and collaboration between multiple AI agents. Unlike traditional single-agent ecosystems, MCP allows agents to specialize, communicate, and coordinate effectively to solve complex tasks. This leads to a faster decision-making, enhanced problem-solving, and more scalable AI systems. One of its key strengths is structured communication, where agents can negotiate rules, share knowledge, and adapt dynamically. With MCP, developers can now build AI ecosystems that behave like more intelligent teams than isolated tools. It marks a significant leap towards building truly autonomous collaborative AI applications. Now, in today's session, we will actually try to work on one, and we will be building a web scraping AI agent using MCP protocols. That said, if these are the type of videos you'd like to watch, then hit that like and subscribe buttons and the bell icon to get notified. Now, we will begin with the agenda for MCP tutorial for beginners. So firstly, we will have a quick briefing of what exactly is an MCP, or as it is called, Multi-Agent Collaboration Protocol. Followed by that, we will understand some basic protocols and standards in communication. Next, we will try to relate MCP to the understanding of protocols and standards. Followed by that, we will get started with our demonstration on developing a web scraper agent using MCP. And for that, we will be needing Node.js, Cursor AI, and Firecrawl API. So I will be walking you through those demonstration steps one after the other, and this will be a very beginner-friendly tutorial and practical demonstration on MCP. Now that I've made myself clear with the agenda, let's get started with MCP. So what exactly is MCP? As MCP on their webpage says, MCP is a Model Context Protocol, or Multi-Agent Collaboration Protocol is an open source protocol that standardizes how applications supply context to large language models. Similar to how USB-C unifies hardware connections, MCP offers a consistent way to integrate AI models with various data sources and tools. Now let's go to the official documentation of MCP to have a broader overview. So, as they say, MCP is one such tool, if you remember N8N and all the AI tools and data sources that you used. For example, if you wanted an AI travel agent, as we have an already existing tutorial on our channel, you can go through it for a brief overview. So you might be needing an email writing agent, and you might be needing an airport code searching AI agent, hotel searching AI agent, flight booking AI agent, and a lot of agents connected to one another through a complex network using an ATEN platform, right? Now, in this particular MCP, that will be minimized. So you will have a standardized approach where you just eliminate all those boilerplate coding, agents, manual searching for databases, manual search for knowledge bases, manual search for agents, which are specifically designed for the purpose. You just explain your initiative, attach the API keys, and MCP takes over and gives you a fully furnished and finished product within no time. That's the main approach of MCP. So here you can see an overview image where we have the parts: MCP host, clients, servers, local data sources, remote services, and local data sources. If you wanted to go ahead with local data sources or local knowledge base, you can go ahead with that. But in case if you wanted some open source, then you can also go ahead with that. So here we have all the quick starts and guides and example and tutorials to how to begin with that one, and all the explore pages that you want to go ahead with if you wanted to have a deep dive into core architecture, the resources available, prompts, tools, transport samplings, and a lot more. And in case if you wanted to contribute your dedicated resources for the community, you can also go ahead with that, and you can also have some support and feedback for MCP. Now that we have a brief understanding of MCP and still clueless about what exactly is MCP, then let's go ahead with some standards and protocols so that you can get a template and you can relate MCP to that template and understand what's the role or importance of MCP in AI agent development. Now, understanding the standards and protocols. Now, let us imagine that you get a team of people to work on a project, and you are the manager that leads and directs this particular team for a purpose, right? Now, the complex problem. No one is friend of anyone. Everyone is new to everyone on the team. And each and every person in this team belongs to a different country and doesn't have a common language in between. For example, person A speaks Mandarin, person B speaks Hindi, person C speaks French, so on. There is no common language between any one of those. Now imagine each and every one of these team members as an AI agent or a tool working for the purpose. In this scenario, you might have to hard code the ports of communication, instructions on how to do, and you need to go on to each and every single AI agent and explain the stuff in a very dedicated and a specific way. This could take a very long time. In the same way, if you relate this to a person, then you might have to reach to every single person and speak to them in their own tongue and explain them the procedures and the steps to be taken to finish the task. Now, how would you do that? It would be a lot complex. Mandarin, you might not even know French or a different language. And in that particular scenario, you might be stuck. What if there was one single language that everyone knew? For example, English. Now you can get all of them together and explain the stuff in one single call and close it. And what might be so wonderful is that you'll not even waste a lot of time, and there is no hard coding, there is no manual effort there. Just let's say you're working on Facebook or Instagram, you try to post something, you try to write a comment, you try to like something, right? That is the activity. And these particular activities will go through 4 different types of requests. One is the get request, put request, post request, and last is the delete request, right? Now, if you are connected to a single server, this might not be as tough as possible. But if you are getting connected to multiple servers, then you might be requiring different protocols every single time. Now, this can be a combination of two parts, HTTP and the URL that you're trying to get connected to, right? Now, to eliminate the efforts between multiple servers and multiple requests at one go, you have one single tool called as API. And the most popular API is the REST API, which has a standard way of communicating. So here, the REST API works as the language English that we discussed before. In the same way, it has maintained a standard where each and every web client can have his communication to his dedicated server or multiple servers in one go using one single language or medium or standard, that is REST API. Without REST API and the standards and protocols, it might be very confusing and you might end up in a complex situation which might not yield in the type of result you're expecting. Now, if you can relate the development of multiple AI agents for a single purpose to the web communication and a meeting, you also expect if there were a template for development of AI agents which could make the process less complex, just like REST API did in a web service and just like English did in a team meeting, then MCP comes into the picture. MCP is your template for it, right? So just like your REST API and the meetings, you have a MCP. Earlier, without MCP, we used to have one tool called NA10, where you had all the tools connected to it and all the LLMs programmed to it, and you had to do this hard coding for each and every tool that you have included in the network and each and every agent that you have related to it. You had to specifically instruct, write down steps, develop a persona to your AI agent, right? There was a lot of stuff. But if you eliminate this particular complexity with one tool, then that would be your MCP. You just had to include MCP and tell your purpose, and your job would be done. Now that you have a brief understanding or a general overview of what exactly is MCP, now let's go ahead and build one. Now, the steps would include the following. For the project that we are building, which is a web crawler or web scraper, we might need the help of Node.js. So firstly, we will install and set the environment for Node.js. Followed by that, we will be needing an editor. So for that, we will be choosing the Cursor AI editor. And next, we will use an API. So for that, we will be using the Firecrawl API. And lastly, we can get started with building one once we have all the required resources. So let's get started. So as we discussed before, we will get started by installing Node.js into our operating system. So we're working on Windows operating system. So we might have to go ahead with Windows. So I'll choose Windows and the architecture will be the one which I'm working with. So that would be x64. But in case if you are working with a different operating system, say Mac OS, then you might have to select ARM or any suitable architecture that you can be compatible with. For Linux, you'll have to choose with the same and so on. So since we're working with Windows, so Windows it is and x64 architecture, and click on that Windows installer MSI file. So it will be getting started to install, and you'll have to click on that Windows installer.msi file and it'll get downloaded. While it is getting downloaded, let's go to the next web page and download and install the Cursor AI that we will be needing for this demonstration today. You'll have to log in, create an account and log in, and automatically it will give you the version that suits our operating system. Since we are in Windows, it gave me a Windows operating system. Just sign up or log in. So since you've already an account, just log into your account and confirm it's that you, and followed by that, you'll have installed your Cursor AI. Choose your theme. I'll go with the Cursor Dark theme. And here you make sure that you have Cursor tab, Control K agent, and you can also choose the data sharing option. I'll go with the privacy mode in case if you want the other one, go ahead with that. And here you have a few review settings, and there you go. Now you're on the new window for Cursor AI. And meanwhile, let's check on the Node.js installation. I think the wizard has already started installing the Node.js setup. So this is the window. Let's quickly go through each and every instance that we have gone through so far in this particular window from the beginning. So it started off with some packages that we would be needing. So yeah, chocolatey and KB299. Yeah, further we have, and the last one is Python 13, right? Version 3.13.3 is approved. So far, so good. I think we can now get started with the next step. So here we are on the Cursor AI. So we might have to get started going through the Cursor AI settings to create our new MCP. So there are quite a few methods that you can try out to reach to settings. One is you can go to the file, and there you may have to choose the preferences, and then you have the cursor settings. You just can use that particular step, or you can go ahead with the search options as well. So you can use that step, or you can also use the other step where you can just go to the search window and search for the settings. Here you can see MCP on the left window. So let me also walk you through a few other steps. So go to the search window and type down cursor AI or cursor settings. I think there has been a discrepancy, but not to worry. We'll go with the regular approach where we go to the file, preferences, and cursor settings. And there you have the options on the left hand side. Go to MCP, and so far you don't have any MCP servers because this is the first time you've logged into Cursor AI. So you just have to add new global MCP server, which is available on the blue color button. Just click on that. And now you'll have a mcp.json file which is completely empty. You'll have to write down a few hard-coded codes here, which are not too complex related to the earlier ones that you have worked on in A10. So you might need a few more tools here. So go to the Firecrawl website. Before that, let's go through some awesome MCP servers GitHub link. So here we have almost all information related to the MCP. So let's open a new window and open all these links. What is MCP, clients, tutorials, community, legend, server implementations, framework, tips and tricks, right? For further information, you can go through all these web pages individually. So back to the home page, here you have everything you needed. The basic information of what exactly is MCP, and further you have some server implementations. Like if you scroll down, so you have awesome MCP services. This is where the beginning is. And next you have server implementations, aggregators, art and culture, coding execution, right? Customer data platforms. So here you have aggregators, art and culture, dedicated web spaces. So, and you have also cloud platforms that you can work along with. And moving further, you have code executions, coding agents, command lines as well, and communication related stuff. So you can go along and perform your operations, customer data or platforms, data platforms, and much more. Let's close all these windows and get started with the next stage where we need an API, right? So for that, the project that we're working on, which is web crawler, we will be needing an API from one of the providers, which is Firecrawl API. Okay, that's the one, Firecrawl MCP. So that's the one. Click on that particular link. Here, to generate an API, first you might have to sign up with Firecrawl. So before we sign up, let's go through the website of Firecrawl from the beginning. So that's the template code that you'll be working on. And also here we have a wide variety of crawl options, media parsing options, smart weight actions, right? Reliability first and all those things. And also we have the pricing details. For now, we'll go ahead with the free plan. And yeah, let me add down my details, my email address, and you might also have to add a password. So let me type down something. Yeah, so the password is not too strong enough. That's a good thing. They have a really strong website. So that's a sign you need to have strong passwords, and also make sure that you don't share your passwords and the API keys that you generate using Firecrawl. Now that my password is a little too longer, I think it should be access. Yeah, it's accessible and it is a successful account generation. Now you need to check your email and confirm that login credentials are right and everything. So once you are signed up, let's go through another website for generating our API keys. So Firecrawl API, scroll a little bit. So API documentation. So here you'll find some documentation related to Firecrawl and all the details that you need to go through for API key generation. So Firecrawl MCP server. Yeah, that's the website that we're looking for. Firecrawl MCP server. That's the one. And here you have overview, content, tools, and other resources that you're looking for. Now, this is the template server configuration that you'll be needing. So make sure that you have an eye on it. And now you will also have the details that you might have to go through, like basically it'll have the steps that you need to follow in the content page. Click on content. There you go. So it has all the features and details that you need to go ahead with. And tools, you have the crawling, extraction, scraping tools that you can work along with Firecrawl, and a few comments here. Now, yeah, the email has not been confirmed yet. Let's try to resend and reconfirm the email so that we just sign up or log in and create our API keys as soon as possible. So there you go. I have verified my email in my phone. So I'll just enter the credentials and sign in. Successful, you are signed in. On the left hand side, you can see the overview, playground, extract, activity logs, usage, API keys, and all the settings. So here you can see my API key has been by default hidden, so I'll not visualize it now. So you have two options, either view or copy. So we will be copying it for the first time to be on the safe side. So since we are new to this particular website, so we don't have any activities registered on this particular web page. So now we have the API keys. Now let's go to the content page to verify the steps that we need to follow. So we need to install npm, and we need to go to the Cursor AI settings and add a new MCP server, which we already did. So we just need to copy the template code and we just need to place it there. And also, don't worry about where exactly to place your API keys in the template. We have that place. So we are back on the Cursor AI. Now we will replace this template code with the code that we just copied. And remember, if you're using Windows, try cmd/c. Okay. If you're not on Windows, you can eliminate that cmd/c. But if you are working in Windows, then you definitely need that cmd/c. Okay, let's erase this and replace that. So I'll name my tool as Firecrawl, and I'll go to the new line where I'll write down my command, and the command will be the code that I just copied from the Firecrawl window. So let me type down the command in double quotes in the new line, and I'll paste the command here, which is the code that we copied from the Firecrawl window. Control V. There you go. So the white stuff, which is in cmd/c, so that's the one you need to focus on. If you are working on Windows, that you definitely need it. If you're not working on Windows, then you can just omit it. Now, there might be some concerns with the codes, don't worry. Now, to cross-verify, you can just go back to the Firecrawl homepage and cross-verify it with the template for configuration that they have made us available. Let's go back to the Firecrawl window, and at the same time, you can see your API key here. So that's where you need to place your API key. So here we are on the Firecrawl window. You need to copy the API key and place it in the place where they have mentioned your API key. So if you have cross-verified with the configuration code, that's fine. And now you can just check the double quotes. So that's the one you need to focus on. Let me if there is a way to zoom it in, let me try to zoom in. Yeah, that's the one, cmd/c. If you're on Windows, you definitely need this. If you're not on Windows, you can just choose to omit it. Now let me just do one last final check. I think I missed a double quote somewhere. Yeah, I need to remove it from this place and add it to the end. Just a second. Okay, remove the double quote at that place. Now it should be after MCP. And once everything is done, you can just quickly choose to save and close this particular window. Check the distance between the API key and the double ampersand places. That's fine. And saving is really simple. Choose those three dots, close, save. And once that is clicked, it's all done. You get to choose to close this particular mcp.json file and get back to your agent. So once you have closed it, you will have your new server that you've just created in the cursor settings. But in a few times you get no tool connected, no server connected, or there might be some errors. So in that case, you just need to cross-verify the npm installation, Node.js installation, and check all the files that are there or not. But even if everything is installed and you can see the versions available, and if you're still seeing this or watching that particular error, then don't worry, just close the Cursor AI and restart it, or you can also choose the refresh option, which is right available there. So I've closed and restarted it, and the same procedure, go to File, Preferences, Cursor Settings, and there you'll see the MCP models, and there you'll find it right there, correct? Now close it and go to the window where you'll find the server. Yeah, that's the one. And here you choose the agent. Make sure that you choose the agent instead of anything else. Not manual, not ask. I choose the agent. And now I'll write down a simple prompt. Search for Simplilearn on Google. Now it should give me results which it finds on Google. Maybe it's a home page, maybe it's a social media handle like LinkedIn or YouTube or Instagram, anything that it finds related to Simplilearn. Only the term Simplilearn. So here you can see it has given me 3 different results. First one is Simplilearn website. Second one is Simplilearn YouTube channel. And the third one is LinkedIn page. So let's get started with the official web page. So click on the simplilearn.com. Now, it's asking me permission, open. Now we are on Simplilearn homepage. Similarly, let's go back and select for the YouTube page. So that's the one. Open again, get permissions. So you're on the Simplilearn YouTube page. Now I think it might ask for a login for LinkedIn. But anyways, let's try to check if it can open without logging in to LinkedIn or not. So yeah, you can see I've logged in to the YouTube. Yeah, it is asking me to log in. So let's quickly log in. It might take a couple of seconds. So there you go. I've logged into LinkedIn. Now open. So I can see Simplilearn's homepage getting loaded in a second. Yeah, there you go. On LinkedIn, we have opened the Simplilearn's homepage successfully.
OpenAI just dropped something huge. It's called Codex. If you're writing code or just love tech, this is about to blow your mind. This AI is not just smart, it rewrites how we write code like for real. But here's the thing, is all this hype actually worth it? We are diving into today. We'll break down what Codex is, how it works, the cool features that make it special, how safe and reliable it really is, and how it stacks up against other AI coding tools out there. So if you're curious whether Codex is a game changer or just a fancy buzz, stick with me and let's get into it. Alright, so what exactly is Codex? Imagine having a supercharged AI developer in the cloud. It's like a team of experts who can juggle writing new features, fixing bugs, answering questions about your code, all at the same time. Codex runs in these safe, isolated sandboxes loaded with your exact code base. So it's working with your code just like a real teammate would. But what powers Codex? A special AI model called Codex 1, trained on tons of real coding projects to produce code that looks just like a human wrote it. It follows instructions carefully, keeps testing until everything works perfectly, and even adapts to your coding style. Oh, and there's a cool fact. In OpenAI's own coding benchmark test called SWE Bench, Codex nailed up to 85% accuracy solving real-world coding problems. That's a massive jump over other AI models. So it's not just a good-looking code, it's a trustworthy code. Now you might be wondering, how do I actually use Codex? Now if you have got ChatGPT Pro, Team or Enterprise, Codex is right there in the sidebar. You just type what you want, maybe write me a login feature or fix this bug in the payment system and hit the code button easy. Want to ask questions about your code? Hit ask and get answers right away. Each task Codex handles run in its own secure cloud workspace. It reads your file, edits them, runs tests, linters, and checks type, basically everything a human dev does. Tasks take anywhere from a minute to half an hour depending on how tricky they are, and you can watch the whole process live. When it's done, Codex commits the changes and gives you all the receipt, terminal logs, and the results, citations, and so you can easily see what it did. You can review the work, ask for changes, create GitHub pull requests, or merge directly. You can even set up a Codex environment to match your real development setup for smoother results. Want Codex to work even better? Just add agents.md file to your repository, like kind of a guidebook telling Codex how your project works, what commands to run for testing, and your coding standards. Think of it like onboarding a new developer, giving clear instructions, and Codex becomes smarter and more helpful. But even without that, Codex is already rocking in OpenAI's internal test. Talking about is Codex safe or not? Look, handing over code to AI can feel scary, right? But OpenAI built Codex with safety first. It runs in locked down cloud containers with zero internet access, so it can't browse random sites or grab sketchy stuff. And Codex shows you everything it does. Log, test results. Even when things go wrong, you can always stay in control. No surprise, just transparency. Now, who's already using Codex? This isn't just theory. OpenAI engineers live with Codex. They offload boring stuff like renaming, refactoring, writing tests, and fixing bugs so they can focus on the cool, creative part. Cisco uses it to speed up features and untangle huge code bases. Superhuman speeds up testing and test product managers do small code tweaks without bugging engineers. Codex helps team work smarter and faster, cutting down distractions and keeping projects moving. Let's talk about the updates to Codex CLI and development experience. If you love working with the terminal, OpenAI launched Codex CLI, a lightweight open source assistant that brings Codex powers to your local workflow. They also made a smaller, faster version called Codex Mini for quick QA and editing. Perfect when you want instant help. Signing is in a breeze now. Just use your ChatGPT account, pick up your API organization, and boom, you're all set. Plus and Pro users even get free credits to start. Right now, Codex is rolling out globally to ChatGPT Pro, Team, and Enterprise users. Plus and Education users, you are next in line. For API users, Codex Mini costs around 1.50 per million input tokens and $6 per million output tokens, with discounts if you reuse prompts a lot. Heads up, Codex is still in early days. It can't yet process images or change course mid-task and remote task. Delegation takes longer than quick edits, but it's evolving fast and will soon handle more complex work. What's next? The future. OpenAI vision. Developers own the work they love and delegate the rest to AI agents, boosting productivity like never before. Soon you'll chat with Codex mid-task, guide it, get progress updates, and assign jobs from your IDE, GitHub, or issue tracker. Imagine a smooth, unified workflow where AI is your teammate across all your tools. Now, how does Codex stacks up against other AI coding assistants? GitHub Copilot is amazing for real-time code suggestions while you type, like a buddy sitting next to you. Codex works more like a remote teammate that handles entire coding tasks asynchronously. Writing features, fixing bugs, running tests, and submitting pull requests, freeing you up for bigger picture stuff. And GPT-4, it's great at code snippets and explanation, but Codex is trained specifically for software engineering, producing cleaner, more reliable code tailored to real projects. Together, these tools form an unstoppable AI coding dream team. But Codex's ability to multitask safely and transparently is pushing the limits of what AI coding can do. So whether you're a solo developer or a part at a team, Codex is here to change the way you build software. It's available now for ChatGPT Pro, Team, and Enterprise, with Plus and Education coming soon. Try it out, play with different tasks, and see how it speeds up with your workflow, cuts headaches, and makes coding way more fun.
Welcome to the short course on Generative AI Models for Beginners by Simplilearn. So in this course, we will learn about the basic understanding of Generative AI. Then we will move on to the C applications of the many GenAI tools. And thirdly, we will understand the GenAI models, and then we will create our first GenAI model. And then we will move on and see the real world impact of the generative AI models. And then we will create a chatbot using the GenAI model. And then we will conclude the course with the limitations of the GenAI models, and finally we will see the future of GenAI models. Now let us begin with the first chapter, that is basic understanding of generative AI. So let us begin with what is generative AI. So generative AI is a type of artificial intelligence that creates new content such as text, images, music, or even code from scratch based on what it has learned. So unlike the traditional AI, which just analyzes or classifies data, like recognizing faces or recommending products, generative AI creates. It's like the difference between a judge and an artist. One evaluates and the other one imagines and produces. So let's break it down with a simple real world examples. The first one is ChatGPT, that is a text generation. So what it does? So ChatGPT, like the one you are talking to right now, generates human-like conversations and answers. So you can ask it to write stories, emails, explain difficult topics, or even debug a code. For example, you say, write me a bedtime story about a robot and a unicorn. The ChatGPT creates an entire story for you on that particular spot. So let's move on and see DALL-E, that is for the image generation. So DALL-E creates pictures from words, that is the text prompts. Then artists and marketers use it to generate logos, illustrations, or more without hiring a designer. For example, you type a cat wearing a spacesuit on Mars, and DALL-E draws it instantly. Now moving on to GPT-3, that is text plus logic task. So what it does? So GPT-3 is a powerful language model that can create and write essays, summary books, translate languages, and even write computer code. So developers use it in apps to create smart features like the AI writing assistant. So then you give GPT-3 a blog title and it writes the full article with an intro, subheadings, and conclusion. So after knowing all this, let's move on and see why are generative models. So generative models are changing the way we create content across multiple fields. So under the text field, we are writing books, articles, reports, or even poetry. And then we are assisting in the customer support with the chatbots. And then under the images section, we are helping the artist generate concepts and visuals. And then we are even handling the speeding up design and marketing content creation. And then under the music part, we are composing the background scores for videos or games. And then we are helping musicians brainstorm the melodies or the lyrics. And then finally, we write the boilerplate code under this coding section, debugging, or even creating full web apps. So now moving on, we'll see traditional AI versus generative AI. So let's compare both side by side with the simple explanations. So the main goal of traditional AI is to analyze and make decisions. And the main goal of generative AI is create new content. For example, under traditional AI, predicting stock prices or recommending books on movies. And the generative AI, we are writing stories, generating images, and so on. So traditional AI handles data. It uses data to classify or forecast, and generative AI learns from data to generate something new. The traditional AI, it labels, scores, and categories as output, and generative AI, the text, images, music videos, and so on. For example, traditional AI is face recognition, fraud detection, spam filters, and generative AI is ChatGPT, DALL-E, Music LM, and so on. So down the line in the next chapter, we will see the applications of some generative AI tools like the ChatGPT, DALL-E, and GPT-3. So imagine this. You are working on a college project. It's late at night and the deadlines is tomorrow. You need a well-written report and a poster design and a clear presentation. So total chaos, right? But what if I tell you that there's an AI assistant that can help you with all of this in just minutes? So welcome to the world of generative AI. Today we'll explore how tools like ChatGPT, DALL-E, and GPT-3 are being used by the students, content creators, and professionals to do amazing things faster, easier, and smarter. So let's break down each tool and see how you can actually use them in real life. So this is ChatGPT 4.0. If you're not aware of what ChatGPT is, so ChatGPT is an AI chatbot that can create, write essays, summaries, articles, explain topics, solve coding problems, and even conduct mock interviews all through one single chat. So let's look at real ways you can use it. So ChatGPT model, it uses this GPT-4, the latest in the generative AI pre-trained transformer that is a GPT family. So GPT-4 is designed for more nuanced and human-like conversation. So have a look at the real ways we can use it. So the first prompt we are going to try is explain the greenhouse effect like I am in class 12. So basically this prompt is asking for the greenhouse effect explanation, and it is asking the ChatGPT to behave that it is explaining to a class 12 person. So we will give this. So you can basically see a human-like generation. Just like here, the greenhouse effect is a natural process that warms the Earth's surface. It happens when certain gases in the Earth's atmosphere trap the heat. Here's how it works. It will have a detailed explanation on the solar energy, Earth's surface absorption, greenhouse gases, heat trapping and all. So after all this 4 points, it has also given without the greenhouse effect, the earth would be too cold to sustain life. However, human activities like as burning fossil fuels, deforestation and industrial processes. So you can basically think it has given one nutshell, and if you just understand this, you have a clear vision of what a greenhouse effect is. So the first point we can see over here is that it is like a own tutor. So the first point, we have just been to ChatGPT, that is founded by chat.openai.com. We have typed a question and we have got a simple and easy to understand answer. And even you can have a follow-up question. Like if I ask, is solar energy related to greenhouse effect? You can even have a follow-up question. Yes, solar energy is related to the greenhouse effect. So it's almost like its own tutor. So great for the late night cramming or the quick concept clarity. So this is it. And now moving on to the second thing that it can help with, that writing assignments or essays in just minutes. So we will ask ChatGPT, write a 350 word essay on climate change for college purpose. And you can see I have provided conditions. You can even customize it by saying make it simple and yet engaging and awesome. So it will basically it has even created a own title, a growing concern for our future. Climate change, it has created paragraphs, and basically you can even customize this word count and topic, then review the generated draft. You can even personalize it. Do you like this personality? And done and dusted. You can just have this. Now writing feels less stressful and it would be more fun. It can even give you an interview experience. For example, just imagine you are having your interview on the next Monday and you are preparing and you're very confused about what to prepare and what not. Then you can basically ask ChatGPT to behave like an interviewer for a particular job. I can even paste your job description from that particular company, and you can ask that what are the probable questions I can have. So let's have a demo. Ask me 3 HR questions for a software development internship and suggest improvements. And you can even post this. And in no time, it has started generating. Here are the 3 HR questions for a software development internship. The first one, can you walk me through a recent coding project you have worked on and explain how you approach solving the problem? And you know what? This is a very, very common question. And it has given one tip also, suggestion. This question evaluates your problem solving skills, your technical ability, and how you approach development tasks. It gives the interviewer insight into your practical experience and thought process. So how do you manage the deadlines when working on the multiple projects or the tasks simultaneously? So this question assesses your time management skills and ability to prioritize the task. So the software development often involves juggling multiple assignments. So this gives the interviewer an idea of your organization skills. So this is very important. It has also written, how do you keep yourself updated with the latest programming languages and technologies? So basically this question looks after your own learning ability. So the self-improvement part. So it has even created one answer over it. And it has also suggestions for the improvement, provide specific examples, highlight the soft skills, prepare for the problem-solving questions, and so on. And for example, if I write, customize it with a data analyst fresher role, having no experience, what all the interviewer can ask me in the technical round, and it will give you answer in no time. HR questions for a data analyst fresher. Why are you interested in pursuing your career as a data analyst, and what are the steps you have taken to prepare yourself for this role? Can you describe a situation where you had to analyze data or solve a problem using numbers or data in your studies or personal projects? How do you approach learning new tools or technologies, especially when it comes to data analysis software? And then we have this technical question. What is the difference between the structured and unstructured data? What is data normalization? How comfortable are you with the data visualization tools? Can you describe a visualization you would use to represent sales data over time? Can you explain what a pivot table is when it is used in data analysis? And there are suggestions that you showcase your learning journey, focus on the problem solving skills, prepare for the basic technical questions. Since you are a fresher, the technical questions may focus on the fundamentals like the Excel, Python, that is the libraries, pandas, and so on. So in no time, it can even have a mock interview over here. So you can even create ideas over here. It can brainstorm you with the ideas available. For example, you have a group project and you want an idea. I'll type over here, give 5 creative ideas for a group project on sustainability. And if you post this, in no time it has created this 5 ideas. Sustainable packaging design challenge. Objectives, design a sustainable. It has created one objective, it has given one approach for you and one outcome. Then it has created community-based urban garden, and for each topic if you see, for each idea if you see, it has created the objective, the approach and the outcome. So these projects can not only be educational but also impactful. So you never run out of inspiration from ChatGPT. So ChatGPT is a lot, and here if you can actually see, it has various search, deep search and create image, and you can basically do everything you want from ChatGPT. Let's now move on to DALL-E. The next we would be seeing is DALL-E. So DALL-E is an AI that creates images from text. You tell it what to draw and it generates the artwork, logos and visuals. So you would be getting DALL-E from this ChatGPT only, and in the Explore GPTs in the sidebar, you have to just mention DALL-E 2. So there are various versions of DALL-E and we'll start chatting. And now if you close this sidebar, you can basically see DALL-E 2. So DALL-E is an AI that creates the images, and DALL-E, this model, uses a version of the CLIP model, that is a contrastive language image pre-training, combined with the VQ-VA2 or other generative image models. So DALL-E creates images from the text descriptions, generating highly creative visuals based on the natural language input. So let's see how you can use it. So, for example, you're going to design the college poster design. So instantly it would be done. So we would write create a poster for a college fest with DJs, neon lights, and a crazy crowd, okay? And you can basically give the prompt. And in no time, it will create one great image for you. You can write and you can see it has created a great image. You can basically download this image and do anything. Here's the poster for your college fest featuring a vibrant DJ scene with the neon lights and the energetic crowd. So forget Photoshop. Let AI do the heavy lifting. So then you can create presentations over here, adding better visuals. So I'll write, draw a cartoon showing water pollution in a river. And you can basically see this. Now you can insert it into the PowerPoint or Canva and design it on your own. It acts as a vector, it acts as an icon, and anything you want to act. Then you can instantly create club logos and branding. So you can even generate a logo for over here through DALL-E 2. Logo for a coffee club with books and steaming mugs. And you can see it has created a drastic logo and it feels like real. So you had just given one prompt and get 4 to 5 variations of logo. You can even ask it for a different version. So great for the student clubs or college events. Then you can even have it for the costume design or any ideas again. So we'll write futuristic costume design for a sky fi play with glowing elements. And even you can see here, it has created a futuristic costume design for a scientific fiction play with the glowing elements. And it is very amazing. The qualities of the images are of high quality. And use vivid descriptions, use more detailed prompts, and you will get a great output from DALL-E 2. So art students and theater class, this is your new secret weapon. So let's move on to GPT-3. Our next GenAI tool is GPT-3. So GPT-3 is the powerhouse engine behind the tools like ChatGPT. So it doesn't just chat, it can write full code, research summary papers, business emails, and more. So GPT-3 is a predecessor of GPT-4 based on the same GPT architecture but with a 175 billion parameters. It was one of the most advanced language models when it was released. So let's explore how it helps in the real world task. So initially we can use ChatGPT because it is a ChatGPT contact form. And in no time it has generated this. You can just copy it, paste it in VS Code or any of the code editors you like, and you can definitely get a proper output of this. Perfect for the beginners or the design students. Then you can even summarize a lengthy research paper. You can have to just upload the paper, and if you see this plus section, you can just click on this. You can just upload from your computer and summarize it in 2 seconds. It can even brainstorm you with the project and the startup ideas, like suggest 5 unique app ideas for college students. Now you can see the first one is Study Buddy Finder. Helps students find partners based on their courses, schedules, and many preferences. And you can even see Campus Event Hub, Course Material Exchange, Mental Wellness Check-in, Foodie Finder, and so on. It has even created bullet points for better understanding. So it is a noise-free study timer. Use it to kickstart your next hackathon or competition or anything. So I'm not dragging it more because as I have already showed you the use of ChatGPT. So that's it. Moving on to the next lesson of understanding the generative AI models. Imagine you are teaching a computer to be creative, like painting a picture, writing a poetry, or designing a dress. That's exactly what generative AI models aim to do. So learn from the data and generate new content that looks sound or feels real. But how do this pull off? Let's break it down into the 3 major families of models. The first one is GANs, that is the Generative Adversarial Networks. Then the second one we have is VAEs. The first one is Generative Adversarial Networks, GANs, the artist versus the critic game. So how it works? Think of GANs like a competition between the 2 neural networks. The generator is like a rookie artist trying to create a fake art. The discriminator is the tough critic trying to tell the real art from the fake. So the artist creates random images. The critic says fake or real, and the artist learns to get better. So over the time, the fake images become indistinguishable from the real ones. So there's a real world analogy. It's like a student, that is a generator, forging a signature and a teacher, discriminator, spotting it. As both improve, the forgeries become nearly perfect. So there are certain applications. The first application is creating realistic human faces. Then style, the transfer in the art. And then we have fashion design prototypes. And then finally we have deep fakes, that is controversial but technically fascinating. And then let's move on to the challenges. So, training instability. The second one is it requires a lot of data and computing. So, moving on, we'll understand variational autoencoders, that is the VAs, the data compressor with creativity. So, VAs are like the compress and the rebuild systems. They take input data like an image, compress it into a low dimensional space that is called a latent space, and then reconstruct it. But here's the twist. The VAs don't just remember, they imagine. So by sampling different points in the latent space, they can generate new similar looking content. So let's move on and see the applications. First application is anomaly detection. So what doesn't fit in the normal data? Then the second one is generating handwritten digits and faces. And then we have data compression. And then finally, we can see drug discovery, that is generating molecular structures. So now let's move on to the strengths. So more stable than the GANs, and it gives a well-structured latent space for the interpolation. So now moving on to the third model, we have transformer models, that is a master of the sequences. So unlike the GANs or the VAEs, which focus more on images, transformers shine in handling sequences, especially the text. The core data idea is attention mechanism, a way to let the model focus on the different words when generating a sentence. So for example, when GPT generates a sentence, I like ice cream because it's sweet. It pays attention to the context, understanding how because relates to the ice cream and sweet. So let's now move on to the applications. The first one is chatbots, like the ChatGPT. And then we have code generation, that is the GitHub Copilot. And then thirdly, we have language translation. And finally, we have summarization and content creation. And then let's move on and see why transformers stand out. So the first one is they scale data well. The second one is they can be fine-tuned on specific tasks like the medical summarization or legal drafting. Then finally we have they handle the long-range dependencies better than the older models like the RNNs or the LSTMs. Then we have a comparison and the use cases. So the first one is GANs, and it is best at image generation. And then we have an example use, that is the face synthesis. And the associated strength is high realism, and the weakness is it is hard to train. Then we are seeing the VAEs, and it is best at data compression, plus it is also good in anomaly detection. So it is used as a latent space exploration. And then coming to the strength, it is very stable training, and then coming to weakness, it has a less sharp outputs. So then coming to the model type, that is the transformers, and it is best at text and language. And then we have an example use, that is a ChatGPT and summarization. And then we have strength, that is powerful with the large data. And then we have certain weakness, that is expensive to train. Now moving on, let's clear something, which to use and when. So if you don't know which generative model to use for what, it can mess things up fast. So let's say you are building an app that needs to write emails, make pictures, answer questions, and turn speech into text. If you use the wrong model for the wrong job, your results will be poor, things will be slow, and you will waste time. So let's understand which models performs what. So for a sharp realistic images, we are using GANs. And then coming to the next, for variation and latent space analysis, we are using VAEs. And then finally, for the language or the text-based task, we are using transformers. So finally, how do these models actually work? So the GAN training process is, the first process is generator makes the fake data. Then the step 2 is the discriminator tries to classify the real versus fake. Then the third step is both get better at their jobs with each round. So the final goal is to fool the discriminator with the realistic outputs. So the transformers under the hood pays attention mechanism. So it helps model understand which words matter more. Then we have self-attention, that is allows the model to look at all the words in a sentence at once. And then we have positioner, that is encoding, and it helps track the orders of the words as transformers don't read left to right like humans. So this is why models like GPT-4 can summarize, translate, and generate in text so well. So understanding the differences between these generative models is like knowing which tool to use for which creative job. So GANs are your digital painters, VAs are the smart compressors with imagination, and transformers are your text wizards. So down the line we'll see how to create our first generative AI model. In this chapter, we will be creating our first generative AI model. So the objective of this lesson is breaking down the steps of building a generative AI model using a pre-trained model. So we are here not training a model from the scratch. So instead, we will fine-tune or directly use a pre-trained model. So this makes it fast and beginner-friendly. So if in nutshell, we will be first choosing a pre-trained model. For example, GPT-2 because it is lightweight and good for beginners. The source from which we will getting the model is Hugging Face's Model Hub, and then we will be setting up the environment in Google Colab as you can see. Then we will be installing the libraries, the transformers, torch, and then loading the pre-trained model and the tokenizer. Then we will be writing a prompt and generating a text. So here we will be using the pipeline API for simplicity and parameters like max length and temperature. So let's begin. So here I am inside this Google Colab and I have chosen. So pip install means install this package in Colab, and transformers is a library by the Hugging complex code needed to run the AI models. So here the text